Unlike printing technology one, where we looked at indigenous and antiquated method of printing. We looked at the antiquated or indigenous method of printing. Those methods are a bit obsolete. They are a bit antiquated. They are a bit, not current, very current. But in printing technology too, we are going to look at the modern trends, everything concerning what we are doing now. How come you have your book today? How come you are seeing a package? How come you are seeing paper? How come you are seeing, what are some of the activities that go on in the printing industry when you visit it right now? When you visit the industry, when you visit the firm right now, what are some of the activities that you would see? Then we would also be introducing you to the careers associated with printing technology. So if any of you is interested, that person could venture into that area. So that is printing technology 2. So once we hear printing technology 2, it is the advancement of printing technology 1. It is the advancement of printing technology 1. It is an upgrade of printing technology 1. So that is that. So let's wait a bit. We have the time is 11:57. Let's wait till, let's say, 12 o'clock, basically, so that we would begin with printing technology 2. I wish all of us a very good interaction, and all that I will entreat all of us to do is to be punctual and regular. Mohammed and co ought to be very, very, very punctual and regular, and also continue with the same level of commitment and excellence. Okay, I know you are doing a good job, and that's so fantastic, and I'm very, very, very proud of all of you. There's something that you need to take note of before we even start. We are sharing some 1 or 2 stuffs before we start. This morning around 5 a.m., someone called me. 5 a.m. and someone called me and claims he did a particular course with me. That was last year, the beginning of last year, January. That is environmental graphics and packaging. And he's calling me to inform me that he has been referred. He had E. And if I could do something about it. Oh, my brothers and sisters, first and foremost, calling me at 5 a.m. It's not official. It's not official. 2, you have had a course in somewhere in 2025, January. The CAs have been released already. Your examination have been released already. And you sat down till now, reaching out. How do you want me to trace back your particulars? I don't even know you. You see, as we are all here, we are all using, our profile pictures. Some of us don't even have profile pictures. Some of you may not know me. Some of you, though some of you may know, the one teaching you. I also don't know majority of you. About 95% of you, I don't know any of you. So the advice is that if you are not punctual, regular, and active over here, and something of that nature happens, I will not be able to trace your records. Though the CA was given to him, the CA, I always publish the CA. So please, I'm going to publish your CA for all of you to look at. That is what I do. I mean, it has been my tradition. All right. I mean, my tradition is that I publish CA all the time for you to see. I will not hide your CA from you, cumulative assessment. I don't hide it. All right. So, which is why we are on the same platform. So I was asking him whether he saw his CA on the platform. He said no. Did you see the CA that was published on the platform not once, not twice? He said no. Then that tells the story of Muhammad, who thought that we are going to buy all the machines, the equipment. When I say it, people laugh. All right. I don't know whether Mohammed is still here, but he's not here. I can see, I can show that Mohammed is not here. If he's here, he should be able to prove us wrong. All right. And so maybe similar thing would happen to some of you. Okay. But but on a very serious note, we need to be very, 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 punctual. We need to be very active. Do something for me to register you in my mind that you are active. Some of you deliberately come here. Okay, we know how online is. Some of you deliberately, put your phone in this mode and go and do something else. All right, as your pictures are here, innocently like that, beautifully like that. Some of you are possibly cooking. Some of you are possibly, you have muted yourself, so you are chatting. You are doing something else. All right. when that happens, the effect is quite serious. Okay, I wouldn't persuade any of you to show video of yourself, because if you want to display video, it will even take more of your data. All right, more of your data. So even if the network is not very strong, you'll not be able to get a very good online discussion. And so, which is why you are using your profile, pictures all over. I'm also using it, Okay, so please, so I told him he should reach out to UCC because I don't have any of his data, because I have given him CA. If once he said he came for lectures and did the presentations, his CA was given, because I don't deny people CA. I will never do that in my life like that. And so those who know me, that's one of my philosophies. Okay. All right. So we'll give you your CAs, best of CAs, so that you can excel in the examination. Yeah. So we are waiting. All right. We are 32 now. Good. So today we are 32. We can commence. All right. So please, on the platform, I could see about 60 something on the platform, but anytime we come here, we are 32, 33. Sometimes before we close, we are about 30, 31. Well, what happened to the gentleman shouldn't happen to any of us. All right. And those who are closer to Muhammad, tell him that we are about to start. And so he should come. And who is our course rep over here? Because as soon as we finish with this, we have to compile the list for the CA. So I normally liaise with the course rep to compile the list. And I'm looking for someone who is very proactive, someone who is having the competence of, ICT. Of course, we are all doing ICT, all right? So that the person can type using Excel and whatever. So, and the person should be able to compile all the list. And we are going to do the CA together right here, right on this platform, when the chance is given to us finally by by UCC. So we are going to do everything right here. Okay, so who is our course rep over here, or who will be in charge? I don't know whether you have course rep already, but who will be in charge? The one who will be in charge should let us know quickly. Who
Yes,
okay, so Emmanuel.
Yes, sir.
Are you the course rep?
Yes, please.
Okay, all right. So it tells that you have been very punctual on my this thing, right? On my
yes,
page.
sir.
Have you been very punctual?
Yes, please. It was only the first week that I couldn't join the class.
Hey, that is dangerous. It's very dangerous to your health. All right. Anyway, please try to be very, 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 very punctual, please, because we wouldn't like a situation whereby some would have issue and you would not be there to give an account. No, even every time you need to be even giving us those who are there, those who are very regular, so that we can award them marks. We can award them apart from the quizzes and whatever the presentation. Those who are very punctual should be awarded marks. Christian, for instance, always, very punctual. I'm not saying only Christian, others are equally very, 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 very punctual. Though we have two Christians over here, one knows that is very much punctual than the other.
It seems you are forgetting your own maybe. So.
Oh, no, Mavis is also punctual. Everybody is punctual in a way,
Oh, the two students are punctual.
I hear.
I was the who last week. I was the one who read through her before you even asked of Christian before I call him. So I was
okay, that's great.
Very
But I didn't mention. I said one Christian. So I don't know why you are.
I'm also a Christian.
I said one. Yeah, so I'm saying that one Christian is very punctual. So it could be you. It could be you. Okay, all right. That's just by the way. That's good. Okay, so we can now start. All right. So in this particular, I've already given you the overview of what we are going to do. So far as printing technology 2 is concerned, the overview, has been given, and I said that it is the advancement of printing technology 1. So in this, we are going to look at.
Hello, sir.
Yeah.
Hello, sir. It seems there is something I would like to chip in here.
All right.
Emmanuel, I don't know whether Emmanuel is a course rep for all centers, and we also have another section that is a UCC and West School.
Okay.
We also have a course rep, but it seems he is not in this class. So we would like to have somebody also from the UCC and
no problem. You can always collaborate. Please, I want us to collaborate on the platform. Okay, it is the platform that matters, because that is more asynchronous. The platform is more asynchronous, so we can always be there. But on this particular Google class is not asynchronous, So that one, once we meet, we go. But the platform exists. So let us collaborate on the platform. So 2, 3, 4 people can still collaborate. I don't have a problem. If all of you want to even be the course rep, we are good to go. All right. So that's good.
All right.
Okay. All right. Okay. So we are going to look at another interesting, very, very interesting sections in printing technology 2. And so the printing technology 2, we are going to look at electronic, unit 1, we are going to look at electronic printing and lithography. So that is an advancement of everything that we did in printing technology 1. It has 6 sections. Then section unit 2, we are going to look at digital printing and industrial printing support, that is papers. And so we are also going to look at everything that we need to know so far as paper or industrial printing support are concerned. So we are going to look at everything concerning that. Then we look at the next unit, which is the next unit is about pulp processing and commercial press activities. Pulp processing and commercial press activities. And so that one too would be looked at beautifully. Then we would look at another one, which is, let me see, another one, which is careers in commercial printing. We'll look at careers in commercial printing. So after careers in commercial printing, we would look at section 6. No, you look at the last section. No, it seems this one ends at section 4, unit 4. So these are, so Alex, the first 2 units we would use today and tomorrow for the first 2 units. Then next week would also be used for another 2 units. So that is what we would do. And we hope to achieve all our learning outcomes. So shall we now? And I've also given you some videos to watch, before coming. And I believe you have watched these videos very well. You have watched them, so that it will be quite easy for us to move. We need to move. If we're able to accomplish everything successfully, we can have ample time on the platform so that we discuss other, all right, concepts relating to the 2 disciplines and possible questions that may emerge in your examination. So it will be in a form of revision if you're able to finish everything on time. And this particular one, I said the narratives will now change. The approach, I have been using expository method of teaching in the first one, where it's more teacher-centered, where I was doing everything, But this time we are going to focus on learner-centered approach, all right, where you are going to lead. We are going to lead the discussion, and I will come in with vivid explanation so that you can comprehend it better. So I wish all of us the best as we share our screen for today's discussion. Shall we begin? Yeah, Sana.
Sir, please, during the exams, are we going to combine the 2 industrial printing 1 and 2 and do at the same time?
Combine it? No, you can't combine it. That is why, you see, that is why I didn't want to teach, all right, it concurrently, teaching one on Saturday, teaching one on Sunday, teaching one. So we are done with a course called industrial printing, industrial technology 1, and there will be questions on that.
Okay.
There will be questions on that. It is a course, it is a course. So we are done with that course. So today we are beginning with another course entirely. So if I had, possibly taught that concurrently, all of you would be confused by now. Okay, so we are starting. It's just like we are done with English language as a course, and we are going to mathematics as a course. That is it. Okay. So we are, so we are doing printing technology 2. It's just an advancement anyway, because that is scaffolding method of learning, where we learn from basic to complex. Okay, so that is it. So we are now looking at the complexities of printing technology. So pay attention as we share our screen for discussion today. So as I said, you are going, so the various course reps, take note of those who will be contributing, reading, contributing, take note of them, write their names down. So if you're about to read, kindly share your official name with us. Though those who contributed in the previous one have not forgotten at all. So we would do that. Okay. So let me quickly share my screen. Okay. Please, can we see what we have on the screen right away? Right.
No, sir.
Yes, sir. We can see.
Yes, we can see it.
Yes, sir, we can see.
Okay. So if you cannot see, it means it's coming from your end. All right. So we will start with the first unit, that is electronic printing and lithography. And so in this particular section, in this particular unit, we are going to look at 6 sections: electronic printing processes, concepts and history of stone lithography, preparation of offset lithographic plates, that is image preparation, exposure, development and preservation of offset plates, offset lithographic press machine, operation system of offset lithographic press. So by the end of this particular section, you will be able to explain the concept of electronic printing. You will also be able to describe the operative principles of different types of electronic printing processes and give the narratives. That's the historical development of stone lithography. You are also going to describe how to prepare our images for offset lithographic printing. Then we are also going to describe how to expose, develop, and preserve offset lithographic plates. Then again, we are going to describe the features of the 2 main types of offset lithographic press machine, and finally describe the operative system of offset lithographic press. So we would now start with what is electronic printing processes. And so we want to look at the concept of electronic printing. We want to look at what is it? What is electronic printing all about? Electronic printing. What is it? That is what we want to look at. So someone should set the ball rolling by reading the concept and scope of electronic printing And the reading shall be done this way so that it will pave way for me to explain the concept to you. So for instance, the term electronic printing is a generic term used to describe all forms of desktop printing or industrial printing processes in which a computer-generated design or image is commanded straight from a PC into the printer for printing. So the pace should be a bit, moderate, consistent, systematic, well-spaced, so that it will pave way for me to explain it for better comprehension. So who is setting the ball rolling? Who is doing that first?
Okay, so I want to go first. My name is
right.
Ajay Emmanuel. Wesco. Okay. The term electronic printing is a generic term used to describe all forms of desktop publishing or industrial.
Okay, Ajay Emmanuel, kindly. So place the course rep. Those who want to be the course reps, take note of Ajay Emmanuel as he reads for better listening, because we'll be taking note of that. So take note. So once you are course rep, you cannot afford to tell us that you were off or you had issues with network. So you need to pay attention, especially. So once again, start, please.
Okay. The term electronic printing is a generic term used to describe all forms of desktop publishing or industrial printing process.
So pause there. All right, pause there. So if you hear of electronic printing, it's a general term. All right, it's a general term that we use these days to describe all forms of desktop or publishing.
Please, sorry, but it seems the line is breaking. Or is it at my end? Please, I don't know.
Your end.
Breaking from where? Breaking from. Yeah. So, can you hear me?
So you are loud and clear.
Okay. All right. Thank you so much. So all that we are saying is that if you hear of electronic printing, what comes to mind is that first, know that it is a general term used to describe. Okay, it's a general term used to describe desktop publishing. So it is DTP. Another name for desktop publishing is DTP. Okay, desktop publishing, DTP. Now, what is the desktop about? Basically, we are looking at you using computer. Okay, the use of computer, where your computer is connected to a printer for printing to take place, or for printing to come out. And so you see, most of us connecting after designing with the laptop or your desktop computer, or after typing with your laptop or the desktop computer, we connect a cable. All right. Some of us don't even connect cables any longer. We use Wi-Fi. All right, connected to the printer Wi-Fi for printing to take place. And so that is it. So we use the computer and a printer. And so the computer is having the softwares that we use to design, software that we use to type, software that we use to generate the document for printing to take place. And so after which we connect it to a particular printer for the print to take place. So that is it. So we said that another name for the desktop publishing is industrial printing process. All right, where we use computer generated design. So we generate our designs with computer. Okay. So we can generate our image, we can generate our text, we can generate whatever that you want to generate. All right. By giving a command from the PC into the printer for printing to take place. So that is electronic printing. So please continue.
Or industrial printing processes in which a computer.
I've explained that already. So you start with these types of. So I've explained where we said this. Yeah. So these type of.
These types of machines are often connected to PC with a cable. It must be emphasized.
So it's okay. It's okay. So I've already explained that it is connected to a cable. It is connected to a cable. You connect your printer, all right, or you connect your laptop to the printer with a cable. All right. So that is it. Let's go. Shall we proceed, please? Is he having difficulty? Is he having difficulty?
I think so.
Yeah, it should. You should position yourself very well, strategically. Okay. And so that we can hear you. If he's not here, someone should proceed, please.
Okay, sir.
Someone should proceed.
Let me continue. My name is Prince from West School.
Okay, all right, Prince.
So these types of machines are often connected to the PC with a cable. It must be emphasized that it is not all electronic printing processes that rely solely on a command from PC to print an image.
All right. Let me explain that. So that to make meaning to you. So we said that the electronic printing is done by giving a command from the PC, all right, into the printer for printing to take place. But we need to also make it clear for you to understand that it is not all electronic printing processes that rely on the giving of command from the PC to the printer for an image to be printed. All right. So for instance, example is xerography or xerographic printer. Xerographic printer. So what is xerographic printer? So xerographic printer is what we call photocopier machine. What we normally call photocopier machine, photocopy machine. You go to the press, you want your document to be photocopied for you. You realize that once you send your document there, you don't need a PC to give that photocopier machine for your document to be printed for you. Okay, so it doesn't need any command. It doesn't need any cable connected to the PC before that document could be printed. All right, so that is what you are talking about. All right, let's go.
Xerographic printers, for instance, can print or photograph an image without a computer command. Some examples
so I've explained that already.
Some examples of electronic printing processes are laser printing, inkjet printing, etc.
Okay. So when you look at the electronic printing processes, basically there are two types of printers that we use over here. Two types of printers generally. All right. In the printing process, there are basically two types that we normally use over here. Basically, basically. All right. We use the laser printing. The laser printing, that's what the photocopier machine use. Laser simply means light. It uses light. Okay. Then the inkjet, it uses ink. All right. Now the laser use what's the name? A medium, a printing medium that is dry. That is dry. All right. So it is in a drum, or it is in a case. All right. It's in a powder form, but the light helps it, all right, to print our items for us. And the other one is the inkjet printing. That one we use ink. All right. It's just like color. All right. Watery. That one is watery. It's color. Okay. The other one is powder. Laser is powder. Powder. And the inkjet one is also watery. Okay. So that's the difference. So most of our office printers, you see that you go and buy what you call cartridge. So the cartridge is having ink in it. Ink in it. So you fill the printer with the ink. So that is what we are talking about over here. Let's go to xerography, please. Another person, let's go. Another person. Another person. We'll give opportunity for everyone to at least do something small. Xerography. Let's go. Your name, please.
This
your name.
Raymond.
Raymond. Okay. Take note of that. Course reps. Take
Ganas.
Okay, Ganas. All right.
Xerography. The word xerography is a combination of two Greek words, xeros, which means dry, and graphian, meaning writing.
All right. So normally we have been hearing the word graphic design. So if you hear the word graphic design, graphic simply means the use of words, text, and images. Graphic. Okay. So the graphian simply means writing. So you realize that graphic design is the use of text, images, all right, to communicate to the general public. Okay. So if you hear the word xerographic method of printing, or xerographic printer, or xerography, this one too, we hear the word zero and graphic. Okay, or graphic. The two or the word is a combination of two Greek words, zeros and graphian. So zeros means dry. So I already said that in the use of laser, we use dry, medium. Okay, dry medium. So you see that the medium of printing, that's the media, okay, or the color is in a powdery form. So it's dry. So photocopy machine, we don't fill it with ink. We fill it with what? What was the name? That dry powdery substance. Dry powdery substance, which is called the toner. Okay, which is called the toner. When you open the toner, you say it is made up of powder. So and the powder is dry. It is not wet. The powder is dry. It is not wet. So the use of dry powdered, let's say colorant. The use of dry powdered colorant to print, to write. That is xerography. The use of dry powdered colorant to write or to print. That is what is called xerography. So xerography therefore means dry writing. Let's go.
Okay. Xerography is popularly known as photocopy.
All right. So when you hear of xerography, your mind should just, so here we are basically talking about photocopy. Photocopy. You know the photocopier machine. So the photocopy machine use a system of printing which is known as xerographic method of printing. All right, let's go.
It was invented in the year.
Isn't someone want to ask questions? Someone would like to ask questions. Where is that?
Yes, sir. Please, it's me, Emmanuel.
Yeah, Emmanuel.
Yes, sir. Yeah. So I've also noticed some printers that actually make use of ink. I wanted to know whether they also fall in this category of xerography or in a different category.
Which one is that?
Yeah, I'm talking about a photocopier machine, which actually uses ink.
Yeah, so there's one what is known HPL3252. HPL3252. That is 3-in-1. Is that not the one you are talking about?
Yes,
it's not the one you are talking about. Yeah. So that one, it's not using, that one is using ink. So that one is using ink. But the one that uses the powdery one, that is the laser. That's what we call the laser. So the one that uses any form of ink is called the inkjet. So that is HP3252 inkjet printer 3-in-1, where it can, print at the same time, scan and make photocopy for you. Is that not the one you're referring to? So it fall within these two categories. So let's go.
Thank you, sir.
Yeah, let's go, please.
Okay. It was invented in 1937 by Chester Carlson, a patent attorney and physicist who was searching for.
So in 1937, Chester Carlson, who happens to be a patent attorney. And so someone who is a patent attorney is someone who is, let me say, someone who is a technologist, someone who is an inventor, someone who protects invention of others, the invention of others. All right. So the protection of that invention is the patent. So he is the lawyer. He is the lawyer for such, protection right of those who invent. It's not just an attorney for patents. It's also a physicist. All right. A physicist. This person is someone who has, studied physics. Physics, knowing everything about, how physics work. So that is it. So let's go.
Okay, sir. He was searching for a method of copying patent drawings without using photography.
All right. So you realize that. So you realize that, someone has patented his drawing. Okay, someone has patented his drawing. So if you patent your drawing, the drawing is yours. So in a way of copying the drawing, he doesn't want to use a photograph or a camera to capture it. So in an attempt to search for another way of course of duplicating or copying that drawing, he came across this particular printing process. So that is it. Let's go.
All xerographic printing process rely on the fundamental principle that Carlson applied in his original device, which states that Unlike electrical charges attract, like electrical charges repel. Xerographic printing.
So you proceed. Proceed.
Xerographic printing is based on 6 major steps. That's charging, exposure, development, transfer, fixing, and cleaning.
Okay. Now let me explain that. Let me explain that. Now you realize that all xerographic printing processes rely on the fundamental principle that Carson, applied in his original device, which he claims that unlike electrical charges attract, while electrical charges, like electrical charges repel. Let me explain that. That's why I placed the video there, how the photocopier machine works. Photocopier machine work. So it works, through the 6 major steps. So the first one is charging. So you realize that when you go to the photocopier, shop or the printing shop, and you want to do photocopy, they have to switch on the photocopier machine for some time for it to be hot. I don't know whether you have observed that they can't just switch it on and begin to do photocopy for you. They have to put it there or switch it on, for some time for it to be a bit warm or hot, or for it to be, that's what we call charging. So, and how does the charging happen? Once it is switched on, a special drum inside the printer is giving an electric charge. There's electric charging over here. So you just have to think of how rubbing a balloon, to make it attract a paper. So it's just like rubbing a balloon, a blown balloon, to make it attract a paper. This charge prepares the drum to receive an image. So it's preparing the drum. So you realize that the charging, in the video, I'll show you the video again so that we'll analyze the video right here, so that we'll see what we are talking about. Then when the charging is done, prepares the drum to receive the image, you will now place your image on top of that glass. Okay, so the printer will take, will take your document from you and place it on top of the photocopier machine on a particular glass. What happens over there? That is when exposure happens. So you charge first, then you expose. Expose what? So this is where a light, a light or laser light draws the image. So you realize that if you study it keenly, once they place it there and give the command, you see that a very sharp light is seen beneath the image. I don't know whether you have observed it. If you look at it, so if you have not observed before, henceforth you go to make photocopy, just look at it carefully. You see a very sharp light passing through the image. All right. So what is it doing? So that white light, white light or laser light draws the image or text onto the drum that has been charged. All right, by removing the charge in certain areas. The parts that are still charged represent the image to be printed. Represent the image to be printed. Then the third one is now development. How is the development done? So after it has been exposed, after it has been exposed, then development takes place. So there is a tiny black powder called toner. So that's the dry toner. The toner is attracted to the charged areas on the drum. All right, that one is attracted to the charged areas on the drum. Just like how a dust, all right, dirt, all right, is stuck to our TV screen that we wipe it. Okay, it is attracted. It is attracted to the drum. This form the image in powder form. So now the image is now. So if you are photocopying letter A, now the letter A is formed in a powder form. Then the fourth process, which is the transfer, the toner image on the drum is transferred onto a sheet of paper. So that toner image on the drum now is now transferred onto a piece of paper that you have placed in the printer. So the paper is also given a charge to pull the toner from the drum. And so that paper too is giving that charge, okay, to pull that kind of toner that has been registered in the drum to fall on the paper. Then what happens then? That's the fifth stage. So the fifth stage, the paper passes through hot rollers that melt. It will melt, okay, and press the toner onto the paper permanently. And that is why immediately you finish printing and it comes out, when you hold the paper, the piece of paper, it feels very warm right after printing. I don't know whether you have noticed that. It will feel very warm. Unlike inkjet, it will not feel warm because there's nothing like charging. Then after the fixing is done, then cleaning will now take place. So fixing of what? Fixing means you are fusing the pressing the toner, all right, with let's say heat, so that it will be permanently stuck on the paper. Then what happens after that one is done? Then cleaning takes place, where the leftover toner on the drum is cleaned off so that the printer is ready for the next page. All right, so that one is wiped off, unless of course you want to repeat it. So you want to print about thousands of A, it will print, it will just be duplicating for you. After that one is done, if you don't duplicate it, what happens is that you have to clean it. So the cleaning takes place automatically. So where the leftover toner on the drum is cleaned off so that the printer is ready for the next page or for the next printing activity to be done. So that is what happens. So we said that xerographic machines are available in black and white. So sometimes you see that this is a black and white printer, but we have colored ones, photocopier machines. So we have black and white. And so if it is photocopier, you will see that the toners are different. So we have black toner, we have red toner, all right? So we have the cyan, we have the magenta, and we have what? What's the last one? Cyan, magenta, and what?
Cyan, magenta.
And what?
Black.
Yellow and black.
No, I've mentioned black already.
Yellow.
So cyan,
Yellow.
magenta,
Yellow.
and what? And yellow. So that is it. All right. So that is how the tone also works over here when we are dealing with that. So if you have any question concerning the distance, kindly ask. Okay, so before we ask any question, please proceed with the last one. The machine consists of, let's go.
The machine consists of feeding, printing.
Okay, so you feed the machine, with whatever that you need to feed it with the document. After feeding it with the document, okay, then you also feed it with the paper that you want to print on. That is the support. Then you print. After printing, it will come out. The delivery aspect will come out. That is, so it contains the feeding pot, all right? Then the printing will take place inside. Then the delivery unit will bring out the print for you. Let's go.
Others have enlargement and reduction capabilities, as well as collating and binding systems. It is used for rapid reproduction.
So you realize that some of the photocopier machines are very big, very big. And so you realize that sometimes, no, very, very, very big ones. So you pack all your papers in it, while you feed it, it start the printing. Before it comes out, it has collected. If you are making book, it will collect it. It will arrange it in that orderly manner. So unit 1, unit 2, unit 3, in that orderly manner, and even staple it for you. Some even staple by binding. All right. They bind by stapling for you. So it staple the document for you. Then you pick it up. All right. So the bigger ones are for rapid reproduction of printed materials and photographs. So for industrial ones, they do that for you quickly. So that is all about xerography. Any question on that before we watch the video? Yes. Yeah. Who is asking the question? Yes.
Emmanuel.
Yeah, Emmanuel.
Yeah, sir. Thank you. And please understand, toners are magnetic substance, and so I wanted to find out during the charging process, which one is negatively charged and which one is positively charged. I would like to know how each of them works.
So let's go to the video. Let's go to the video.
Okay,
quickly.
sir.
And okay, so in this video, you realize that we have placed the image on the distance A on the photocopier machine. Then this is the drum charging. Okay. This is where the toner is, the black toner. And this is, we are charging, so the whole drum is charging. So as soon as the light go through it, it will pick it, all right? Pick it, then give it to the drum for the positive areas to register on the drum, leaving the negative areas. Then the positive areas which is registered, now that black tone is now coated on that positive area. So you can now see the A, leaving the negative area. All right. Now, when that is done, the paper then enters. Okay. Now enters to register the positive areas which has been picked by the drum. So that is what we are talking about over here. So that is all about the photocopier machine. So we have another one that we can watch. So let's see which one can we watch again.
Hello.
Yeah, he's looking for video.
Yeah. Okay. Okay. Thank you.
Sorry, I went off. I don't know where I got to before I went off.
So you were showing us you on
So
printed.
have you watched the video? Have you finished watching the video?
Yeah, we just watched the first, the second one. That was
No.
when
I mean, I was showing you how photocopying is done, and I gave a narratives of how it is done. Did you watch that?
Yeah, after the narrative, that's when
I went off.
Went off.
That's when okay.
When you were about to show the second video.
Oh, okay. So I didn't even show second video at all. I didn't even show any second video. I didn't even show the second video because I realized that the second video is lithographic. All right. So I didn't even show the second video at all. So that is it. So that is all about the xerographic printing that we are talking about, or photocopying, that we know of. So that is what happens. And I said the one who asks that question should also be, inked down. The name should be inked down. All right. The CS, you all get it, but all of us cannot get 40/40, 50/50, and whatever. There should be variations. And so the variation will come in when you contribute to the development of this section. So there will be variation. So if you want to get a very good distance, you need to contribute to that. So please, the course reps, kindly put that on record. All right. Okay. Yes, Eric.
Yes, sir. Please, I want to ask if the machine is able to pick all form of materials, or it's only paper-like materials that the machine can pick.
So you realize that for now, what we know of, apart from other printing this thing in photocopy machine, we photocopy document such as paper. We photocopy document on a film. You can photocopy document on a film, right? But just that it may not appear very clearly. So the most suitable is paper. So that is it. But you cannot photocopy because we need to cover it for laser to take place. The laser must not be watched with our naked eye. Okay, it must not be. It's a very sharp, concentrated light. Okay, that we even cut. So we don't expose it. So which is why it must always be covered for that to take place. Unlike the 3-in-1 inkjet printer, it doesn't use, laser, okay, to pick it. All right. So you see that there is nothing like laser over there. And so let's take note of that.
Okay. Thank you, sir.
All right. Yeah, Eric.
Yes, sir. Sir, please, I remember ever witnessing somebody photocopying without covering the part where the glasses, where the laser light is projected. Sometimes people put the document on it raw, and then the light gets exposed. But now, giving us a brief idea that the light could be harmful. I don't know why people do that.
Yeah, lesser could be harmful. Lesser is harmful. Not even a very sophisticated laser is used for operation. Okay, it can even cut through your skin. It can cut you into pieces. So I don't know whether you have heard of laser security light before. You can't pass through. It will cut you to minute. To cut you into minute. So laser is a very composed, very composed waves of light. Okay, that we mustn't joke with. We are Ghana, as we have been joking with everything. We have been joking with everything. Everything we want to joke with it without reading the consequences of that. It must not be exposed. We don't expose lesser. Okay, we don't expose it. If you see people doing that, yes, I've seen it before. I've also seen people doing it, but I will not entreat it. We are going to talk about safety precautions, so I will not. It is in the wisdom of the white, which is why they made it with a cover. Okay, so that is it, Eric. That is it. All right. Shall we proceed, please?
Yes, sir.
Okay.
Yes, sir.
Yeah, Osman.
Yes, sir. Looking at the photocopier machine.
Osman, were you the one who said those items would be bought?
No, please.
Okay.
No.
Okay, all right.
No, please.
Okay.
Okay,
let's go.
Okay, sir. Looking at the photocopier machine, whenever you are about to print something, and also whenever you are to do the scanning, to my end, actually, I see the printing to be more clear than you scanning it. I don't know the reason.
You see it to be more what?
You see, when you are printing it direct, that one seems to be more clear than you scanning it to run a
but for photocopy is photocopy. Photocopy is replication of a document. Are you can we get a copy of you? A copy of you means that you are is not the original. So the copy is a substitute of the original. So you don't expect the original or the copy to be better than the original. It will still, so original stuff will always come very clean and neat and precise than something that has been, photocopied. All right. Anything original is original. So that is it. Okay. Let's proceed quickly.
Sir, please, sorry, before that, I've also seen some photocopying machines that has scanners within. I think they put it there, they scan before they do we have something like that, or is a printer rather?
Because no, as I indicated, we have 3-in-1. So
yeah,
that is we have the 3-in-1 as I earlier stated. We have the scanner, we have the printer, and the photocopier. So once you scan, if you are scanning, it means you are scanning for photographic purposes, for image purposes. So that one you scan, you capture the image down. That is scanning. So scanning means to capture the image down. Okay, to capture the image down. So that is scanning. And so that image that you have captured can equally be printed. And so that is it. All right. Let's continue. All right. Let's continue. I was having a very beautiful interface. I no longer see it on my distance, where I could see you at the same time, see the document I'm projecting. I don't know. Maybe I will have to explore it and see. Okay. So okay, so it has come. Okay, so that is laser for you. Now, let's go to laser. We are done with the xerography. So let's come to laser. That is one of the printing methods. Let's go. Who is reading?
So answer someone is reading.
Answer someone. I like the way you are contributing. And I hope the various course reps are taking notice of that. Yeah, taking notice of that. Contribution is about contribution, participation. Okay. If you're all good to go, it goes, I mean, like that way, it will help. So that all of us can be very active. In a way, it's a way of checking whether you are also online or not. It's a way to check whether you are online or not. So when we mention your name, 1, 2, you are not there, it means possibly you are preparing fufu somewhere or you are playing Ludo somewhere. Let's go. All right.
Okay, sir. Laser printing is a marriage between xerography and computer. The laser is an acronym for the phrase light amplification by stimulated emission of radiation.
That is the meaning of laser. Don't forget, light amplification by stimulated emission of radiation. So that light has been, you know, the light that is coming as a result of radiation has been amplified, has been increased. Okay, it has been increased. So it's very sharp. So light amplification, all right, by stimulated emission of radiation. That is laser. So we say laser is a marriage between xerography and computer. Okay, so that is it. So laser printers employ. Let's proceed.
Laser printers employ the 6 basic printing process of xerography.
Just like how I explained that.
However, the light source is a concentrated beam of light, which could be reduced to the smallest beam that it is capable of microscopic precision.
Yes. So the microscopic precision over here means that it gives a very minute details, because the light, the light is very sharp, extremely sharp, very small. So laser printers, their printings are very sharp, precise. That's all that we are talking about. Okay. The printing, if you print with laser, you print with inkjet, you see that they are very sharp, very, very sharp. Let's go.
The main distinction between xerography and laser printing is that the laser beam light source can be controlled by digitized information sent from a conductor with a laser light source rather than through reflection from an original image.
So the one which is the reflection from an original image is the photocopier.
Okay.
And yes, is the photocopier. Reflection. So you put your image on the screen, it reflects it, it takes the information, it prints out for you. But the laser, sometimes we control digitized information. We give a command and it does the printing for us. Let's go.
Laser printers use toners and are electronically operated.
All right. And so we have indicated that they use toners, and that is a powdery, substance, colorant agent. And so that is that. When you open it, realize that the toner is made up of powder. All right. Okay. Now let's go to the other one, which is the inkjet printing. Inkjet. Inkjet.
Inkjet.
Yes, maybe after that, someone else who can also read and will explain it quickly.
Okay, sir. This is a printing process in which an image is produced by transferring individual drops of ink from an orifice.
Orifice.
Through a small air gap with a printing surface.
Okay. So we are looking at, if we say that inkjet, we have explained that one is using ink. Okay, yeah. Ink. And the ink, we have an opening, a metallic opening, that is the orifice. That metallic opening, which is called the orifice, ink will come out from that area. All right. Then it will spread. All right. It will spread over the piece of paper or the area for the printing. So the orifice, all right, that is where the ink comes from, through a smaller air duct to a printing surface. So that is how it happens. So inkjet printing relies on computer input. Okay. So you have to connect it to the computer. You have to connect it to the computer. Then once you connect it to the computer, you give a command based on your designs. Once you give command based on your design, it would print that. So if it is one color, which is black, the orifice would be one. So it will be moving up and down, up and down, up and down, making the printing for you. So there's a particular place we call it the printing head. If you open it, you see the head moving, or left, right, as the paper is coming out. It is also moving. It has picked the signal. Once it picks the signal of the image, all right, it drops the ink in a dotted form. It drops it in a dotted form. And so you will not be able to see with your naked eye, but it's very minute. So it is the dot that spread all over. It is the dot that spread all over to make it very smooth for you to see. All right. So it moves from left to right, as the paper comes out slowly for the image to be registered. Okay, so that is so we have most of the large format printers, those that we use for banners, billboard. We call it plotters. Large format, printers are known as plotters. P-L-O-T-T-E-R, plotter. All right, these are very big. All right, large format distance. So it's for billboard. So we print it. We print some on stickers. We print some on paper. We print some on what you call flexi materials. They are rubber like. So that is the nature of inkjet. So we have office jet, okay, inkjet, and the rest. Okay, let's go.
Sir, please, is it the same as using printing the backdrop?
Backdrop, yeah, it's the same.
Oh, okay.
Okay.
Inkjet,
now let's go.
Is with the last.
I've explained that already. Let's move. Yeah. Operative principle of large format inkjet. Another person. Operating principle of large format inkjet.
Okay.
Another person.
Okay.
How how does the operation happens? What principle does it follow? If you go to the press, the plotter, very big printer, okay. If it is one color, if it is different colors too, we fill it with different colors with various orifices. So the orifices are attached to the various, colors for the printing to take place. Let's go. Let's go. Your name, please.
Okay. Shadrach Asamoah.
All right, Shadrach, let's go.
Shadrach from Ghana. So the printer is first switched on. The printer is first switched on, and the printing sheet is loaded into it. The same design, the soft copy.
Okay, you finish with the first paragraph. So I'll explain it.
Okay.
Finish the first
so
paragraph.
The same design, soft copy. Okay, so the same design, soft copy is opened on the PC and commanded it to print through the printer. The sheet is fed into the printer through metal rollers, and upon entering into the printer, it is transferred through series of rotating metal rollers where a light sensor identifies the colors in the design, whilst the printer head moves left and right along the length of the roller that carries the sheet and spray the colors gradually onto the sheet to print the design or image into a hard copy. The gradual spraying of the colors slow down the printing process.
Good job. So all that we are talking about is how the inkjet work, the large format printers work. That's the plotter, the one that we see, okay, printing our banners, whatever for us, our billboard. That's exactly what we are talking about, how it works. So the first one is that you have to switch on your printer. You go there, you see that it is on, it is connected to power, okay. Then they load the support into the printer. So the support can be a sheet of paper or fleximat. So the material that we print banner on, that's what we call fleximat. Okay, flexi material. Okay, so the same design that you have done, whatever you have saved, or whatever you have done is now saved, all right, on the PC. It is open on the PC. Okay, don't forget the soft copy of the printer has been installed. The software or the setup of the printer, so that there will be connection. Okay, it has been installed on your computer, so that when there is a command, it will affect the computer. It will affect the printer. When there's a command on your computer, it will affect the printer. So the sheet is fed into the printer through metal roller. So there's a metal roller that would now be pulling the paper or the support gradually as it is printing. So one thing is that once the command is given, there is a light sensor that identifies the colors in the design. All right, which makes the head of the printer where the orifice is, which makes the head of the printer moves from left to right. All right, just to cover the entire sheet of paper. Okay, they sprays the color gradually onto the sheet for the printing to be made. There is one thing, because it is spraying the color, the orifice is spraying the color gradually for the image to be printed. It makes the printing very, very slow. So it goes very slow. All right, it moves left, right, to cover the entire distance. It moves on to the next stage for the printing to be done. That is what happens. Let's go, please.
Okay. So note that large format printing machine.
Someone want to ask a question? It seems someone want to ask a question first. So let's go. Yeah. Dalcom, please ask your question. Oh, please read. Continue reading.
Okay. So note that large format printing machines print with all the colors. So when one color gets finished, the other colors cannot print. They can also print designs on only one.
Take note of that. Yeah. Take note of that. One, you exhaust one color. If it is taking 6 colors, some take 6 colors, some take 3 colors. Okay. Some even take more than necessary. Okay. Then if one let's say cartridge is finished, it cannot work because it works together. You have to fill it before it, else you are spoiling the head of the printer. Let's go, please.
Okay, so they can also print designs on only one side of the sheet.
Okay.
Also, when the design is bigger than the length of the printer, the printer can be commanded to break the design into smaller size, into a method known as tailing, and print them onto separate sheets so that they will be joined to form the full design before and during mounting.
All right, so let's take note of it's okay. Let's take note of the one asking question, please. I'll call you. Let's take note of this. The very big billboards that you see, all right, mounted in cities. Have you ever thought how the printing was done? The printing was printed because it is very big. The printer, broke it into smaller sections. So it will print, all right, cut and join. So eventually we join all, then we make it so big. That is how it happens. So that is it. So we can see large format cartridges. So a lot of them. So this is an example of plotter. This is an example of plotter that is inkjet. This is printing out the whole print. Any question now? We are done with that. We are done with that electronic printing. Yeah, we are done with electronic printing. Any question, please?
Please, I'm Dr. Prince. For all centers and then Techumai to be precise. I wanted to be sure on this. I saw there was no white color for the printers, and I wanted to be sure whether it takes the white color from the background, right?
Yeah, it takes the white color from the background.
Oh, okay. That is what I wanted to be sure of. All right.
Yeah. So that is it. All right. Thank you so much. All right. Yeah, Eric.
Yes, sir. So please, with the cut and join that you mentioned, can you give more clarity about it? Is it that the paper or the sheet is the one that is being cut and joined, or it is the images that is done digitally?
Okay, so let's
I had the opportunity to print the same backdrop for a concert yesterday, and I think I can help with the cut and join. Okay, so I designed the backdrop for the concert, and then it was too big. It was 16 feet by 8 feet, and then the printer was and the printer was supposed to print with the height. It was supposed to print, I think, 84 feet. With the 16, it could print, but with the 8 feet, it had to divide it into 2. So after printing the half of it, so we divided the work, which is the part that is
the design. Yes.
Yeah. We divided it into 2, which is 4 feet by 4 feet. So we earlier printed the 4 feet by 16 feet, and then later printed the upper part, which is the 4 feet also by 16 feet. After that, we decided to join. After printing everything, we joined it, which is we placed the upper part on the top part and then the lower part, and also at the end of everything, we joined it with that is the 99 glue, and then we also add it was petrol, which for it to dry faster. That was what we did in joining it.
That's fantastic. So that is how we join. Some even sew it. Some also sew it by joining. That is if the material is very durable, all right, the calipo type. Okay, so we join it. So that is how Darkon explained it. So if your work is going to be big, the printer, it's having size, else it cannot enter your room. Okay, so if your design is going to be big, you are going to divide your design into two. All right, the two, or how many, it depends on the size. It is several sections depending on the length on the breadth of your printer. Okay, so if you can take 4 feet, you divide the 4 feet. So if you are doing about 16 feet, it means you have to divide it into 4. Okay, then you print one part first, then you print the other part, you print the third part, you print the last part, after which you join it together. You join the materials together with the glue. So that is that. Okay. Yes. Any other question? All right. So thank you so much. We are done with section 1. So we are going to lithographic, the history, the concept of lithographic printing quickly. So the lithography. Now we want to look at two methods over here. The lithographic, printing. We want to look at two methods over here. Okay, the two methods, one is indigenous, one is contemporary. Now, for you to understand the contemporary one, you need to understand the indigenous one, which is why we brought the indigenous one here. We even said something briefly about the indigenous one in printing technology 1. Okay, so we in this one we want to look at the concept and history of the stone lithography, after which we move on to the offset lithography. Then we exhaust that one too quickly. Okay, so let's look at the concept. But before then, we saw, what did you watch? All right, on that, on lithography. Tell me what you watched. Tell me what you watched. Lithographic. Anyone? Anyone? Am I online or I'm gone? I believe I'm online.
Yes, sir, you are here.
Yeah. So tell me. I gave you, about 2 videos or 3 videos to watch on lithography. So anyone? Or you didn't understand that? Okay.
All right, so it was I think the man was using a kind of stone. I don't know if it is a limestone or something. Yeah. So he engraved a design, like I think the head of a python or a snake, or I don't know if it was a duck on it. Then he applied some oil. I think there were 2 types of oil, so lacquer or something on it, and he rubbed it. First, he coated it, and he coated it the second time, and the last one he applied, you realize that the paint or the ink on the object went off. Then he also applied it another time, and later they also brought in ink to cover the whole place. They brought a paper and rolled the paper. They placed the paper on the stone with the image and used a roller to roll on it and put it down. Then during the printing, they brought another paper, but when they rolled it, the picture of the object they engraved on the stone was printed neatly on the last paper. Please, that is what I saw.
All right. That is a nice description of what, or narrative of what you watched. Quickly, let's go into it and understand the video better. Let's go. Yeah. Someone should read the concept before we come to the video. Someone who is reading. Another person.
Okay, so my name is Christian.
Christian is reading first. Christian, try as much as possible to mention your full name so that we'll be sure of the one reading. And,
Christian Soglonu is my name.
Okay, all right, let's go.
Thank you. So lithography is the printing process in which the image is created to lie flat on the image carrier. In other words, it is a method of printing from a flat surface. The basic principle behind the printing is that water and oil do not meet.
So what's the difference between lithographic printing and maybe engraving? What's the difference? In printing technology 1, we looked at intaglio. So what's the difference between lithographic and intaglio?
I think with the etching uses an acid-based substance.
Okay.
Yes, and lithography is more like stone printing, where images are drawn on a stone and has been forced through on a surface, on a flat surface.
Yeah, you have done well. And any other? Any other?
And so what I know for some time ago now is when we talk about lithography, we are talking about litho means stone in Greek. So and we know graphic means printing or drawing. So stone printing.
Okay.
So lithography means stone printing.
Okay.
Yes,
okay,
sir.
so the key difference is in how the image is created. And where the ink sits. So in intaglio, all right, where we looked at engraving, grave, all right, etching and co, we said that the ink is held in grooves. So you realize that we created grooves below the surface of the plate. All right. So in lithography, the ink sits on the flat surface. The first one, the ink, settles in the grooves. And we said that the deeper the groove, the deeper the impression. But this one around, it is down on a stone, a very flat surface. So the ink sits on that flat surface and is guided by a chemical that will repel it. So a chemical repulsion of oil and water, where we know very well that oil and water do not mix. So there is a chemical or a grease, something that we use to draw. So you realize that the man was using grease to draw. draw the image on the stone. Okay, so that is what we are talking about. Then, if you look at it very carefully, so you see that intaglio is like carving and filling with ink. Then the paper pulls the ink out of the grooves. Okay, while the lithography is like drawing with grease pencil on a wet surface, where the ink sticks only where the grease is. So the ink would only stick at where the grease is. So where there is no grease, that one, it means that there is no ink over there for the image to be printed. So let's go. So we say that this is lithography, stone writing, litho. All right. Litho is stone. Litho is called stone. Stone. Graphy means writing. So stone writing. You say it's a process in which the image is created to lie flat. Unlike engraving, you create grooves. So you realize that the person was using pencil to draw, and that pencil is grease-like. It's oil-like. Grease is oil. In other words, it is a method of printing from a flat surface. A flat surface. So the basic principle behind it is that water and oil do not mix. You cannot mix water and oil, it will separate. So where there is grease, where there is oil, the ink will pick that one. Okay, and because there is no grease on the other part, which is the negative area, the ink, there will not be any form of ink for it to register over there. So when we wipe it and put our paper on top of the stone and press it hard, it will bring about where the ink is. So that is why we say that water and oil do not mix. Please proceed. Who invented? Let's go.
Okay. So Alois Sennefield.
So Alois. This is called Alois. Yes.
Alois Sennefield invented.
Yeah. Sennefielder. Yeah. Sennefielder. Yeah.
Sennefielder invented lithography. He was born in 1771 in Germany.
So Alois is a German born in 1771. Let's proceed.
He was a young actor and playwright who stayed in Munich in Germany in the 1790s. Due to the high cost of copper plate etching.
So that is due to the high. So due to the high cost of what?
Copper plate.
Which is under what? Which is under
etching.
Which type of print? No, so etching. No, etching. Etching is under what?
Intaglio.
So yes, intaglio. So the intaglio process, we have the etching, we have the engraving, and so on. Due to the high cost, he decided to experiment with other materials to discover a cheaper way of printing some of his plays. Because he wants to write down some of his plays so that you not forget. He's a playwright. All right, he's a playwright. So he wants to document some of his play. He cannot be documenting it using the intaglio process, which is the etching. Very expensive. So he experimented with various materials and hence discovered a cheaper method of printing his play. Let's go. Eventually, let's go.
He experimented with several materials to discover a cheaper method of printing his play. Eventually, he was able to invent a new printing method called lithography. In his experiment, he wrote his laundering list on a smooth Bavarian limestone with a compound consisting of wax soap and lamp black. He immersed the stone in acid, and surprisingly, the list appeared on the stone in extremely low relief. He developed the process until it became formalized.
All right. So that is how come he also came about the word lithography, because he made use of stone. He made use of stone. So that is that. So lithography therefore means writing on stone. In lithography, two main methods are used to prepare the image carrier. So stone method and plate method. Don't forget, the stone is just like a metal plate. A metal plate. So this one is that the image is drawn. The image is drawn. All right. Then coated, drawn with what? The grease. The grease crayon or grease pencil is drawn. Then coated. All right. The image. So we'll now look at how it is done. So let's go.
Stone
method. Yeah.
Get a flat, smooth limestone.
So you see that the surface of the stone must be very flat, very, very, very flat. So you have to sharpen it. You have to sharpen it. You have to sharpen it. All right, to make it extremely sharp and flat. That's a stone, and that's a limestone. Let's go.
Draw or write the image on the stone in reverse with a greasy material such as
so with a greasy material. So after you have to draw whatever you want to draw, you have to write whatever you want to write, all right, in reverse. Okay, with a greasy material. So the greasy material is what? Oily. Don't forget, it is oily. Yes, so that greasy material which is oily, that's why you say oil and water doesn't what?
Meet.
Doesn't meet. So you have to draw it on the surface. So this one is drawn on the surface in reverse. Okay. Then with what? A lithographic crayon or a greasy ink known as touch. So that is it. Let's go. Immerse. Immerse. Next one, please.
Immerse the design stone in a
weak. It's done. Okay.
Nitrate.
Your network is equally giving us a challenge.
Okay, immerse.
Yeah, you went off.
Immerse the design stone in a weak nitric acid and leave it for some time, and then remove it from the acid. The acid will etch the non-grease part of the stone and leave the greasy parts in low relief.
All right. So that is it.
Apply
Apply
a coat of gum Arabic on the entire surface to block the void on the stone.
Okay. So the gum Arabic is a solution. Okay, is a solution that we apply on a surface. It's just a binder that we apply on the entire surface to block the areas. Sometimes we have to block the areas so that no amount of the negative areas, we have to block it, coat the whole area before the distance, so that no amount of this thing will even spill out when you are printing. So now we go to the printing process.
Printing process 1. Damping the surface on the stone.
So you damp the surface of the stone.
The water will wet the non-greasy areas of the stone.
All right, don't forget that it is the greasy area that is having the image that you have drawn. So once you dampen it, the water would wet the negative areas, leaving the greasy area. All right, which is the image.
Okay. 2. Work out the printing ink on a glass plate with a brayer.
Okay.
3. Apply a layer of the printing ink to cover the entire surface of the stones. The ink will stick on the greasy images. Sorry, the greasy image.
Okay, so once you apply a layer of printing ink to cover the entire surface, you wipe it. Once you wipe it, the negative areas will wipe out, and it will stick at the greasy area, because the negative area contain what? Water. So it will wipe out. So you realize that he decided to wipe out the negative areas. All right, let's go.
Okay. So
the ink.
The
ink will stick.
The ink will stick to the greasy image areas, and however,
repel
by the water-soaked background areas. The ink receptive areas, that is image areas, are hydrophobic or water repellent, whilst the non-image areas are hydrophilic, accept water, and ink repellent.
Okay. So as I was saying, once this thing is applied, layer of ink is applied onto the surface, you wipe it. Once you wipe it, the ink will stick to the greasy area. Okay, the greasy area where there is no water. But where there is water, once you wipe it, it will clear. All right. Because we know that the negative, the image area is hydrophobic, okay, or water repellent. Then the non-image area are hydrophilic. They accept water and ink repellent. So the next one is to put your piece of paper on the ink stone, okay, and press it evenly with the help of either a roller or a presser to transfer your image. After it has been transferred, you remove the printed sheet and dry it. So it means that you have made your print using the stone method. So that is that. Any question before we go to preparation of offset plate image preparation? We want to look at offset lithography. Any question? Offset lithography. We have lithography and we have offset lithography. So any question on that? Any question on the previous one so that we talk about that? Yeah.
So when you were explaining the lithography method, how it pulls colors to print, you made mention of groups. When you are referring to the integral printing, so what is the difference between the groups and the bands? The best.
So the best, you realize that one becomes more rough. It's also a form of groove, all right, but it's not. The best are quite roughs, all right, roughs that are done on this. So it's still groove, but the groove more definite. So that's why we look at the etching, we look at the engraving, we look at the grave, we look at others. Okay, so they are all a form of creating groups.
Okay.
Right, but the best, that one, it is more rough, not so specific. So that's it.
So the groups are sharper than the bells.
So in all, there are all forms of group, but one is, more sketchy, and so the bells are more sketchy.
Okay.
Okay.
Thank you, sir.
All right.
Yes, sir.
Yes, sir.
Please, my question is, though we are doing this for examination sake, but with this you have just spoken, how effective is it or efficient is it in Ghana here or done? Because this is the first time I've seen it and then heard of it. Thank you.
So for us to appreciate offset lithography, which is done in Ghana, there's a need for us to look at the genesis, the origin, how it came about from initial stage, which is why we are looking at the stone and the plate one, okay, the stone one and the plate one under the lithography are all antiquated. All right, something that was done in the past. It is based on the antiquated ones that we are now seeing offset lithography. So we will be learning about offset lithography. Okay, so we want to look at what is offset lithography at all. So when we come to offset lithography, we realize that in general, lithography is a general printing method. Lithography simply means it's a general printing method based on the principle that oil and water do not mix. If you're talking about offset lithography, it is the modern high-speed version where the image is first transferred. So the transferred aspect is what we call offset. Offset means moved. The image is moved onto a rubber blanket before printing on a paper. So you realize that under we have the stone, we have the plate where the image is transferred on the stone. The image is transferred on the stone or the metal plate. Okay, with a grease, let's say a crayon, a lithographic crayon. Good, but because of modernity, the modern one of the lithography, which is the stone and the plate, the modern one is what we call the offset. Offset. Offset means to move. Offset means to transfer. Okay, so this one, we don't use the stone. We don't use the stone. We don't use the metal plate where we put the paper on it and press it with our hand or with roller. No, this one is a machine. Okay, it's a well-designed machine. And this well-designed machine is modern, that we are currently using it today, right now. Today, it's still in use. And they are high-speed printers where the image is first transferred onto a rubber blanket. So there's a rubber blanket that the image is transferred onto it before printing it. So the process of transferring the image onto the rubber blanket is what is known as the offset. You are offsetting the design onto the rubber blanket before the printing is made on the paper. Please, are you paying attention?
Yes, sir.
Good.
Please, sir.
Good. So before I land, so offset lithography is the most widely used commercial printing process that we see today. You should go to everywhere they are using the offset printing process. The offset printing process. Okay. So the lithography, as I already indicated, all right, it was invented in the 1700s. all right, and where we have the principle that greasy images areas attract ink, while non-greasy images repair it by using what? Water. Okay, so in the offset one, so that is the idea, that's the general idea, that's the basis of which the offset printing, you know, has been invented. And so when we talk about the offset lithography, once again, it's a mechanical way, all right, of developing the traditional, you know, lithography, which is designed for mass production. So that is it. Please, your question. You wanted to make an input. Yes.
Hello, sir.
Yes,
sir,
sir.
the printing press, they are using something called a master or master sheet or a plate. Does it have any relation with this one that we are teaching us?
Yes. Yes. So this one will have a plate, a thin aluminum or polyester plates that are used. So the image is first transferred from the plate to, so you get the plate. So you go to the say, let's make a plate first. Then your plate. So you go to Abosokai, Accra New Town. That is or where they use it, even Koforbia, those in Koforbia. All right. You go there, that's why they print a lot of, you hear them mention the word, oh, let's develop our plate first. So the image that you are going to send to them and the soft copy that you are going to send to them, they are going to use it to develop their plate. And the plate is a thin aluminum or polyester plate. Then after that, after developing that plate, okay, this one is not stone. After developing the plate, then we now go to the offset process. So plate development, then we go to offset process. So the offset process, the image is first transferred from the plate to a rubber blanket. So this is where we call it the offset, where the image from the plate is transferred onto a rubber blanket. Then to the paper finally. All right, to the paper finally. So once it is transferred onto the paper finally, we now see the listing printing, whatever image that we have printing. So I'll be showing you video. There's a video over there too that we'll be watching so that it will also clear our mind too. That is the offset. Okay. So
thank you, sir.
It. Yeah.
So it means that the plate will not be for direct printing, but rather to be transferred to another surface. Okay.
Another surface, rubber blanket. Okay. That's why the name came. That is why, remember, all of you take note of and underline the word offset. That is why the name came about offset. Offset means transfer. Unlike the previous one, you see that we were putting the paper directly onto the plate or onto the stone. This time around, the plate has the image. The image is now transferred onto a rubber blanket that is, revolved on the drum. There's a revolving drum that moves on it. Then you slot in your paper. Okay, then the paper picks the image on the blanket. So that paper that picks the image on the blanket, the impression is placed on or transferred onto the paper. So that is the offset. So that one, they use full color. So we have full color, they are all there. So the first one, the feature, all right, we transfer the image directly from, all right, from the plate onto a rubber plate. So plate to rubber, blanket, then to paper. Unlike the traditional lithography, where from plate to paper, the offset lithography is from plate, then moves to rubber blanket, then moves to the paper. So that is it. So the surface type, unlike the traditional one, so I'm giving you the difference. So unlike the traditional one that the surface, the image carrier is limestone or metal. The offset lithography, it is what on aluminium or polyester plates. Aluminium or polyester plates. Now, when it comes to the ink application, I'm giving you another example. If it comes to the ink application, the manual, the traditional, one is done manually or semi-automatic way, where we press with maybe with the help of a device, or we press by hand manually. Then when it comes to the offset, that one is a machine, it's a printer. So that one is automated by rollers. There are rollers. Roller is just like cylinders or thread. When the one that we buy and for sewing, the thread, right? The roller or cylinders. That is it. You saw it in a video. Then what the uses for both, okay, for the traditional lithography, that one, it's basically used for one particular artwork. Maybe you are drawing someone or a building or whatever, just one. Okay, but when it comes to the offset, because it is automated, it is this thing, we can print various, workbooks, newspapers, packaging in mass production. A day we can print more than 1,000 pieces, books and co. Okay, then when we come to the printing quality of both, all right, the manual one is high, okay, is high, but that one is handcrafted, okay. Then the offset one is also very high, consistent, and very fast, okay. So that is how I can give you the difference. So in simple analogy, ladies and gentlemen, in simple analogy, the lithography is like hand painting or a design on a wall. Okay, don't forget, it's a stone. While the offset lithography is using rubber stamp to quickly produce a design, all right, in several times, okay, hundreds of times. So that is that. I hope I've given you enough differences for you to get better understanding. All right, Frank.
Sir, I want to know how the image gets onto the plate for printing.
Okay, so we have plate development. There's a plate development. We'll come to that. So you see that session 3, we are talking about preparation of offset. So preparation of the offset, that is where we are coming to talk about image preparation. That's, we are coming to talk about this. I mean, the session 3, we are talking about plate development, preparation of offset lithography plate. So we'll develop the plate first. So that's what we'll be looking at. Then before, we proceed. Okay. All right. Let's go.
Okay.
Anyone again? Raf, is it Raf? Raf. Okay. So yes, Christian.
Can we say the lithography supports only one color print, and the offset lithography supports polychromatic printing?
Yeah, polychrome. Yes, of course, that one is more modern, so you expect it to be. Even that one, even it can still be this thing, but it can even support one. Okay, it can be offset. What if your document that you are going to print is black and white document? I hope you get the point now.
Yes, sir.
So but it will become more complicated. You can still use the polychrome for the stone one, but just that you are going to suffer. You are not going to get it easy. Okay. You can still do that. Yeah.
Yes, sir. So the offset lithography supports color separation.
Yeah, color separation. Exactly.
Okay.
That's good. All right. Yeah. Frank, once again. Yeah. Your hand is up.
Sir, sorry, it's the previous one, but let me add something, if I'm getting it right.
Okay.
It means that with the offset lithography, it is the plate which picks the ink, then transfers it onto the blanket, then onto the paper.
Okay.
Is that it?
So the plate picks the image, not the ink. The plate picks the image. Okay. That is the image carrier. But because the plate is giving you the image carrier, it needs for it to be very sharp and very sharp. It has to place it on a softer distance, a softer image, a softer image carrier. That's a rubber blanket. So from the plate to a softer one. Okay, that one, makes it's more finished. So finishing take place over there. So it is that one that is carrying the ink.
Okay.
Before it is printed onto the paper. Please, are you okay with that? Okay, so let's proceed. But before we proceed, it is now 2:08. Let's go and drink some water. Today we need to finish with unit 1. Don't forget, we have to finish with unit 1. Though I like the way you are all contributing, fantastic, and I love that. So we have to, if we don't finish, I thought tomorrow we will be able to finish and go a bit into whatever. So we have to at least try and finish unit 1. So we are on session 3. So session 3 we go to 4, 5, 6. Okay. So we give ourselves let's say, how many minutes should we give ourselves? 10 minutes? Will 10 minutes do?
15.
15 minutes to go and do what?
Sir, 10 minutes is okay.
10 is okay for us.
15 minutes to go and play some Ludo small or watch a movie. Why is that our friend who wanted us to purchase, is still not around, right? All of you should take notice of him. Which center is he? Which center is he? Who knows him? Which center is he? Master, we are not laughing now.
I'm sure you be UCC and West Coast.
West Coast, do you know him? West Coast people, do you know him? Samuel, you said you are maybe Samuel West Coast. Do you know him?
Sir, the reason why I'm saying that because some all centers, let me say, as for whole center, whole only center, like we are only 8, so we know ourselves. So I'm sure you'll be from UCC and West School. We are not many like that.
Okay, all right, but he's still not here today too, and you shouldn't go and buy photocopy for anyone. You shouldn't go and because I've placed photocopy over there, so you shouldn't dare go and buy that one in addition. After buying it, you can establish himself. So it's a nice one. If you even buy, you can establish yourself. So let's give ourselves some 10 minutes. Okay. All right. Thank you so much. Some 10 minutes will do.
Started hearing the planes around 2 a.m. Local time, and
Okay, are we back? Are we back? Yes. All right. If you are back.
Yes, sir, we are back. We are back.
Yeah, so let's quickly, if you are back, let's quickly watch the process before we start the preparation of the plate. Once again, how it works. So this is a diagram of the process, how it works. So we'll look at the diagram. Diagram right here. A video diagram of the whole process, offset. Let's say the detailed one. There's how it goes. Let's watch. So this is how it goes. So we have about 1, 2, 3, 1, 2, 3 rulers. Okay, so we have 1, 2, 3 rulers. The cylinders, 1, 2, 3. We have the ink over here. We have the water over here, and other rulers. Other rulers too are there. So we have the printing plate. So you can see the printing plate on one of the rulers. Okay, all right. Now, once the printing plate is there, we have the blanket cylinder or another printer on another ruler. Okay, so don't forget there is water. There's water that is added to the non-grease areas. Okay, then this printing plate is registering this ink onto a blanket, cylinder, which is sharper. So it is the printing plate with the ink, all right, which is on it, is registering it onto another surface. So this is where the ink now is. So the ink is now on the blanket cylinder, but not on the plate again. The plate takes the first one and applies it onto the blanket cylinder over here as it revolves. Then the impression cylinder, that is between the blanket cylinder and the impression cylinder, there is a piece of paper. Okay, there's a piece of paper. So it is that paper that is coming out, moving one by one. Okay, moving one by one between the blanket cylinder and the impression cylinder for printing to take place. So let's watch it once again. Let's watch it once again. So you can see what is happening now. So this is what happens inside. This is what happens inside. This is what happens inside. I hope Edward is watching. Yes. He said I have low battery, so let me connect it quickly. Okay. All right. So that is it.
Offset lithographic printing. It is more than just operating a machine.
So
you need to study the entire process, its structure, its properties, and to understand the interaction between the water, ink, and paper. The design of the image and text is laser etched and transferred onto multiple sheets of aluminium called the press plate. One press plate is mounted to a cylinder in each printing unit.
Okay.
This machine has 6 printing units. Each unit prints one color. Color printing typically uses ink of 4 colors: cyan, magenta, yellow, and black. The color model CMYK. For this job, we will be using 4 of the printing units. The stack of paper is lifted into position. A sheet separation unit separates the paper with jets of air or a vacuum to ensure that only one sheet is sent through the press at any one time. As the press plate rotates, its first point of contact is the dampening unit. This has a mixture of water and other chemicals. This dampens the non-image area of the press plate.
So
the press plate then passes the inking unit. Starting from the ink fountain, the ink will pass through multiple rollers called a roller train, which then sticks to the image area of the press plate. It is then passed to the blanket cylinder, which squeezes the water and the inked image area is picked up. It is then passed to the final cylinder called the impression cylinder. The paper runs between the impression cylinder and the blanket cylinder, pressing the image onto the paper. The paper will then run through the transfer drums. Each cylinder is equipped with grippers that pick up the paper from the previous cylinder and transfer it to the next. Once the prints have passed through each unit, they will then be dried with hot and cool air and placed on the delivery file. And that is the process of offset lithographic printing. Thank you for watching.
All right, so that is it. Thank you so much for watching. Thank you so much. So that is it. All right, Chris.
Okay, sir. So I think this one is more like color separation. That is why they
Yeah,
have
yeah, exactly.
Okay, thank you,
Exactly.
sir.
All right. Okay, so we are now continuing. Someone should read preparation of the plate. Don't forget, we use plate first, so we want to see preparation of the offset lithography plate. Image preparation, how the image is prepared first. Okay, so we want to look at how the image is prepared first before we move to the next one. So let's proceed. Who is doing the reading for us?
I'll read.
All right, thank you. Quickly, let's go. We have seen the video, so this time it will be a bit fast. Let's go.
So
types
of images reproduced is offset lithography.
Okay.
Yeah, so we have in offset lithography printing. Two main types of images are produced: vector or line image and bitmap or continuous tone image. Continuous tone image.
All right. Okay, so let me explain this one so simple for us to get, so that there will be no need for us to read all. Okay. In image preparation, in computing, in image, we have two main types of producing an image or reproducing an image. Okay, if you design something, it is designed or produced in two main ways. So we have vector or line image. Vector or line image. Now, that is one of the ways of producing your image. Now, there is a software that we use to design called CorelDRAW. CorelDRAW. This CorelDRAW is a software that we install on PCs. We use it to design posters, all right, graphic design works, basically. Now, that software use vector way of producing image or design vector. So CorelDRAW is vector based. Vector based. If you say something is vector, another name for vector means it is line. Line. Okay. If I ask you to draw a line on a piece of paper, can the line break? Does it break into particles? Does it break into particles?
No, please.
It doesn't break. Please. All right. Okay, so if I ask you to draw a line right now, you draw from here to China, and the line will remain the same. True or false? True. True. Okay. It's true, because the line can be stretched. What you can stretch it from here to cover the entire world. It is still a line. It is still a line. Okay. Now, this line is what we use to produce image. So once we use it to produce the image, which is vector, so the line is another name for the line is the vector. So whatever we want to produce, whether image or whatever, we use line in the production, the picture qualities become very, very, very sharp. When you want to expand the picture, if you want to enlarge it, you see that you can enlarge it multiple times, billion times, it will remain the same because it is made up of lines. The picture is made up of lines. So it's like various lines are joined together. You can't see the lines because they are compacted, joined together. So you are seeing it to be flat. They do not have anything like tonal values. Okay, they are compressed lines. Okay, if something is not having tonal value, it is also known as silhouette. Silhouette, everybody, silhouette. Okay, now the silhouette, just like what it is, an image, all right, a flat image with a white background. Silhouette simply means a flat image with a white background or a plain background. A flat image. So I place it on the platform. Okay. Now, once that one is done in vector compression of lines, that is used to form an image, that is used to form a design, that is used to form anything, and you finish designing it, please, the picture quality remains intact. It remains intact. So the examples of line images are test. Let me give you an example. Let me show you how vector is. Are you there? Are you there?
Yes, please.
Yeah.
Yes, sir.
Yes, sir. Let's look at the image. Is that example is letter? Are we still seeing the quality remaining same? Is it still intact?
Yes.
Is the quality still sharp? It's still sharp,
Yes,
right?
Yes, please.
Okay. All right. So no matter how you increase it, it will remain very sharp. It doesn't change. That is what we call vector image. Vector image. So vector image can be done or generated with computer-aided designs. Okay? Computer-aided design like the Cora Draw and whatever. So these days we see it, a lot of them. Now, let's look at the difference. Let's look at the different vector so that I will explain it for you to get, so that you get it better. Now, what about vector? Now, this is a vector. A vector is an image. That one we use dot. Vector is dot. Dot coming together. Whilst vector is using lines, bitmaps. Sorry, the opposite of vector is bitmaps. Bitmaps. Okay, so we realize that we said we are going to look at we are going to look at the two main, that is vector and bitmaps. Another name for bitmaps is continuous tone. Continuous tone. Now, let's explain the bitmaps. Okay, let's explain the bitmaps. Now, the bitmaps, unlike the line, dot is dot. Is that not so? Dot is not continuous. True or false? Dot is a small round spot.
True, sir.
True. Dot is just a spot. It's a small round spot. So dot ends at a place, whilst line do not end. The line do not end, which is why no matter how you expand it, the quality remains unending. It doesn't end. The quality remains intact. But dot, if you want to make it, if you want to extend dot, what do we do? If you want to extend dot, what do we do? If you want to extend dot, what do we do?
So we create a line.
No, if you want to extend dot, we have moved from line. We are saying that line can move an ending. If you want to extend dot, if you want to make it more, what do we do? If you want to extend it,
I think you have to expand it.
If you want to expand it, what do we do? What do we do? If you want to
So
expand
add
it, what do we do?
another dot to it.
You add another dot to it. You add another dot to it. So over here, it is picture that we take, pictures. So bitmaps are pictures. Bitmaps are pictures or photographs. So when you look at your photographs, it is made up of tonal variations. They have tones. That is why you can see that it is in 3D. You see the thing so real. Unlike vector that is flat, bitmaps are having tones. All right. So when you take a picture of yourself, you look like, or the picture looks exactly like you. It's not flat. It's not so. It's having tones. Tones means it's having 3-dimensionality, which is light tone, mid tone, and dark tone. Now, the continuous tone image of the bitmaps, what happens is that they are also called, all right, raster. Raster. Bitmaps or raster. So another name for bitmaps is continuous tone. Another name for the continuous tone is the raster image. Raster image. What happens to the raster image? Now this dot is known as pixels. The dot that we are talking about is known as pixels. So if you need to expand your dot to cover a place, to cover a box, you have to put several dots together to cover a particular place that you want it to cover. Okay. Now what happens is that dot is called pixel. Pixels. So it is the pixels that cover the entire area. So pixel is a dot. In ICT we call it pixel. So it is the pixel that come together to form an image. So the dots, they come together to form the image. So the pixels are not often, they are not often visible with our naked eye unless you expand it or you magnify it. So when you magnify the image, you will see that the image will begin to break into dots, into squares. Let me give you an example. Let's give an example of an image that will break into dots. Let's look at this image, for instance. Look at this image. You see that the image is beginning to what? It's beginning to break. Please, are you seeing it? The quality is not remaining same. Are you seeing that dot is coming out from the edges?
Pixelating.
Are you seeing it?
Yes, sir. Yes, sir.
Good. It is pixelating. So another name for it breaking is called pixelation. So the image, because it is made up of dots, once you are magnifying it, once you are expanding it, it is pixelating. It is breaking apart, making the resolution or making the picture quality less. So that is why when you buy phone, the camera is what? Is that we have how many, whatever, camera, the camera is calculated in what?
Megapixels.
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 Megapixels. So the megapixels is a mega of the dot. How big the dots are in a given space. So the bigger the megapixels, means that the dots that are supposed to be there are more. So the more the dot, the more the picture quality. So 1 megapixels against 20 megapixels, which one will have the highest picture resolution, picture quality? Which one will have it?
20 megapixels. 20 megapixels.
20 megapixels. Why is it at 20 megapixels? It's just like, have it at the back of our mind that, okay, 1 megapixel simply means one dot. It will easily break. Then 20 megapixels simply means 20 dots. Then one, before it breaks, it will have to take about 20 times before it can break. Please, I hope you get the point now. So the picture qualities are calculated. That is why in television, when you buy television, We have 2080p. We have 1080p. 1080. We have 720p. Most 20p, 720p, 1080p. All right. So the pictures of your flat screen television, if it is 720p, it means that it is 720 pixels. So you see that someone using 1080, that's what they call HD, high definition pixels. Okay, so the high definition pixels picture quality will be more than or sharper than 720 pixels. The same way, if you have what's the name? So we have high definition, then we have 4K television. I use 4K television. So if you use 4K television and someone is using 1080p pixels and someone is using 4K, which one will appear sharper and nicer and more, original? Which one?
Okay.
The 4K simply means it is 4 times of the 1080. 4 times of the 1080. That's what it means. So 4 times of the 1080. So 10,080 pixels. 1,080 pixels added. 2,080 pixels added. 3,080 pixels added. 4, making it 4K. 4K. It means that the picture quality is ultra instead of high definition. It is now ultra. Please, I hope I'm making meaning over here.
Yes, sir. Yes, sir.
Great. So that is it. So today we are having cameras and what's the name? Televisions that are 8K. 8K. If it is 8K, it means that the 1080p will go into it how many times? The 1080p will go into how many times?
8 times.
8 times. So 8 times means that it cannot be compared to 720 or 430 or 70 or 10 pixels.
Never.
So never. So when you take a picture with high megapixels, it means that the dots are high. The dots in the picture, in the photograph is more compacted. So the more compacted the dots are, the better the picture quality. Because the dots are many, the pixels are many. But if the dots are not compacted, it will pixelate easily. It will break. Hence, once it breaks, the picture quality will reduce. So in short, vector images, no matter how, the vector images are sharper than the bitmap images. If you want bitmap images to be sharper, that means that the pixels must be very, very high. Please, have I explained all that to you?
Yes. Yes, sir.
Great. That is yeah. That is great. Let's go. Yes. Someone was asking a question. Oh, it wasn't a question.
Sir, it was a response to you.
Oh, okay. Thank you so much. Thank you so much. Thank you for getting that understanding. So you realize that I've explained all this for you to get. Is that not so? So that is yeah. So that is in reality. So that is in reality. So we are saying that so let me quickly read it faster so that we move. So we are saying that in the bitmaps, which is also known as the continuous tone images, this one, the photographs or pictures have tone, all right, in them. They are also called bitmaps or raster images. The photographs consist of number of individual dots called pixels, which align and overlap to each other to form the image. The pixels are often not visible with the image unless a portion of the image is projected or magnified. It is the size and the quantity of pixels in the image that determine the sharpness or the blurriness of the photograph. So the sharper the image, the more pixels it's having. That's the meaning. So the sharpness or blurriness of a photograph is measured in the resolution. So don't forget, how is the sharpness or blurriness of a photograph measured? It is measured in resolution. So the resolution is made up of what? Pixels. All right, pixels. Okay, which is represented with numbers and abbreviations. So the number range from 72 to 300 in designing. In designing, it ranges. So in CorelDRAW, it ranges from 72 to 300. Okay, and the abbreviation is DPI, dot per square inch. Dot per square inch. The higher the resolution, the sharper the image. While the lower the resolution, the blurrier the image. Therefore, a photograph of resolution of 300 dpi will provide a sharper image than one with resolution 20 or 72 or 100 or 200. Note that the resolution higher than 300 must be input by the artist. So you can get more resolution, but you have to put the value over there. It means it's going to be very sharp. So the banners, the billboard that we print, that our friend printed, all right, because he wants to print it very big, then he has to increase the resolution of the image. So in offset lithography, continuous images are printed with trichromatic colors. Okay, that's translucent inks. Example of continuous, yes.
Sir, please, I can't see the screen.
Oh, you can't see that, it's coming from you.
It's your hand, though.
You can see the screen. Sister, you have to magnify or use the full screen so that you can see the image.
Who is talking?
David.
Yeah, maybe you can't see, but I've explained that already. So you listen more. Listen to this one more.
Yes,
all right,
please.
because you don't have any image yet to show you. So listen more. Okay, so know that, as I said, know that if you want to get a higher resolution, just like our friend who printed the backdrop, you realize that he has to increase the resolution so that the images will be sharper. Okay, so in offset lithography, continuous tone images, that is bitmaps or raster images, are printed with triachrome. That's 3 colors. All right. Examples of continuous tones are, all right, examples of continuous tone tone images are charcoal, pencil, and crayon drawings, painting, and photographs. It's an example of continuous tone. Okay. Now, to print a continuous tone image in lithography, the tones must be broken into individual dots. So we are producing the image now, must be broken into individual dots to produce a half-tone image. I have shown you how a half-tone image is done, all right, on the platform. So you realize that it is made up of dots. So let me quickly show it to you again. Half-tone image. So this is the half-tone image. Half-tone image. So you realize that it is made up of dots. But when you compress it, you see that the whole thing is one image without dots. That is how it is. Okay. Now, the ensuing subtopic will discuss how vector and bitmaps images are prepared for offset plate making. Number 1, how to prepare vector image. So I've already spoken about vector image and spoken about which one? Bitmaps or raster, or another name for raster or bitmap is known as what? Everybody is known as what?
Continuous.
Continuous. Thank you very much.
Continuous.
Thank you.
So
another name for vector is known as what?
Line.
Line.
Great. Great. So ladies and gentlemen, you can now understand why there's the need for us to do 1 before we go to 2. Please, I hope it's clear.
Yes, sir.
Yeah.
Yeah. We have to do 1 before we go to 2. So you realize that this one is very sophisticated, but the understanding is going on well. Is that also?
Yes, please.
It is so.
Yeah, maybe so. Okay, so let's go. Now let's look at how to prepare vector image now. How do you prepare the vector image? 1. So the vector image. Okay, explain.
No, I would like to read so that you do the explanation.
Okay, read it. All right. So let's go.
How to prepare vector images. 1. Generate a text or design or image with PC to the correct size and paint with the appropriate flat colors or tones.
So how are we going to generate the image? How are you going to generate? We are generating the image before.
Cora.
Everybody, we are generating the image before. Cora Draw.
So you can do that with Cora Draw.
On what? On PC, right?
On
PC. It's not about paint and brush. No, it's not about pencil. It's on PC. Let's go. Next. Before we move on, David, before we move on, let put this thing down, write it down, write this one down, write this information down. It may come to your examination. Write it down. Now, Cora Draw gives us vector images, while Photoshop gives us bitmaps. Take note of that. So Photoshop is about image, bitmaps, raster, all right, raster images. Photoshop. So those who deal with Photoshop, you see that Photoshop is more or less layers. So we have to put one layer on top till we get a better image. So that is it. So that is it. So Photoshop is for raster or bitmaps or continuous tone, while Cora Draw is for what? Vector or line. Thank you very much. Okay, so let's continue, David, quickly.
Number 2, separate the tones by selecting some colors in various parts of the design together and group them.
All right. So this one, that is when you are doing color separation. So you have to separate the tones by selecting same color. All right, same color in the various parts of the design together and group them. So there is a tool on the Cora Draw. We say group and ungroup, group and ungroup. So you group the group. That means you put them together. Let's go.
Okay, so you do so for the other colors in the design.
So for the other colors too, you have to group them. For other colors, you have to group them. Right. You separate the tone and now select the same color and group them. Let's go.
Select each grouped color and paste on a different sheet.
Okay. So every color that you have grouped, all right. Every color now that you have grouped, you now paste it on a different. So in Cora Draw we work in sheets. Okay, we can work in sheets. So first sheet, second sheet, third sheet. So the first sheet, you put it on it. Then another color, second sheet, you put it on like that. Let's go.
All right. Recolor each of the separated colors black and use a letter to indicate the what word is that? The colors or
the colors on the sheet. Now we realize that we are going to prepare a plate. Because we are going to prepare a plate, this in the plate preparation, it has to be in black and white first. So because it has to be in black and white, you have a color distinct that you want to do. So you convert the colors now, all the colors into black and white. But don't forget, make sure you label it so that though it is black and white, the first design, make sure if it is yellow color, you put yellow over there, but still make the image black and white. Then the second sheet, if it is green, you label it green, but you make it still black and white. The third sheet, if it is indigo, you write it indigo. You indicate that it is indigo, but you still make it black and white. All right, let's go.
All right. Then print each color onto different laser films. Oh, what is it? Sorry, let me take it again. Print each color onto different laser films with deep black opaque colors.
Okay, so now you have to now print it. You have to print each color that we have labeled red, gold, green. But all the red, gold, green are black. So now you have to print it on a laser film. So the laser film, don't forget, in the printing technology one, we made mention that if you don't have laser film, what do we use? If someone is able to tell me that, it means that the person, I can award the person with some marks. Yes. And
tracing paper.
Tracing paper. That's good job. Good job for all of you. Good job. So 1 marks for everybody. Good.
Thank you, sir.
Yeah. Yeah. Hey, 1 mark is not easy. 1 mark. You know, 1 mark is not easy at all. All right.
Yeah.
1 mark is not easy. You see the significance of 1. You will see the significance of 1 when you are failing. Maybe you have 49. 49. That is where you see the significance of 1. So when you are failing, you know, when you are failing, we don't pray for A. When you are failing, we pray for A. We don't pray for A, we pray for pass. Is that also? There you see the significance of 1. Then when you get B plus, then you are praying for A. Then when you get 79, then you see that, hey, artistic should have given us 1 pair. And Kamenya 1 pair and Kamenya A. Charlie, David, they try me with only 1 mark. There you see the significance of 1. So that is how the whole thing is. All right. So I've given all of you 1.
Sir,
yes.
From your speech, are you implying you are commonly known by many as artistic?
Yeah, that is it. That is it.
Okay. Nice name. Okay.
All right. So so all of you can call me artistic. You don't need to mention my full name. Artistic, and we are good to go. Oh man, artistic. Let's go,
guy.
All right. Okay. So now let's look at how to prepare. So we have finished preparing the vector. So now let's look at how we will prepare the raster. So someone should read it for us. Another person, David has read. Another person who has not read today. Quickly.
Raphael is reading.
I'm reading.
Okay, let's go.
How to prepare half-tone images. Half-tone images are continuous tone images which have been broken down or converted into pixels.
We have said that already. Good job. Let's go.
The conversion is done by separating or processing the pixels into 4 colors, namely cyan, magenta, yellow, and black.
Great. So cyan, magenta, yellow, and black. So the conversion is done by separating or processing the pixels into 4. The pixels into 4 colors. All right. With a machine called image sector. The machine called image sector. Let's go. The full color.
The full color image is edited with Adobe Photoshop.
and
why is
commanded.
it edited? Why is it, Raphael? Why is it edited in Photoshop? Why is this thing edited in Photoshop? Because we said that half-tone images and bitmaps are for what?
Pixels.
They do with pixels, and they are meant for which software? They are meant for which software? Photoshop.
Photoshop. Adobe Photoshop.
One vector is for what?
Corel Draw.
Let's go quickly, because we have to close.
And commanded to separate the colors into halftones, and printed each image onto separate laser films through an image setter by a network system. Each halftone image is indicated on the laser film for easy identification, like the figures below.
So look at that. So it's the same image. It's the same image, but one color is cyan, one color is magenta, one color is yellow, and the other color is black. So when they put all together for the color separation, just like how the printing takes place, all right? Someone said color separation. It takes place. That's the same way. So once you print it, you print one first, you print the other on top, you print the third one on top, then the final one you print it for the color to all the colors to come. So that is all about that. So we are finished preparing our plate. So that is how the preparation of the plate is. So now we have to now develop it. Exposure, development, and preservation of the plate. All right, materials used to produce the lithographic plate. So don't forget that the materials used, that one, the materials used to prepare the lithographic plate are zinc, aluminium, stainless sheet, okay, chromium, and thick paper that can also be used as image carrier. That is it. So the thickness of the plate ranges from 0.005 inches to 0.0030 inches. So the size of the plate is equal to the surface area of the lithographic press cylinder. Nowadays, plates used to expose images for lithographic production are pre-sensitized. So pre-sensitized plates are plates in which one side is coated with a light sensitive chemical. All right, this chemical is a compound that we learn about photo emotion. All right, sensitizer. All right, so that is it. All right, so that is how to expose an image. Now let's go to how to expose. So we know that materials used is zinc, aluminium, stainless steel. We know that the size is between 0.005 inches to 0.030. That is the most important information that you have to take note over here. Then we move to the how to. I'll let you read, Raphael. I'll let you read.
Okay. How to expose an image in offset lithography.
Before then, Raphael. Before then.
Yes, sir.
When are we closing today? When are we closing?
It's 4.
It's 4.
Yes,
I believe we'll finish before 4. We'll finish before 4. I think we'll finish before 4. We'll finish before 4. Let's go quickly.
Okay. Though the advent of,
we will have to finish 1 unit. Well, we are still on 1 unit too, so it's not easy. We are still on 1 unit, so we want to finish 1 unit. At least 1 unit today will be okay for us.
This is compatible.
Okay, let's go.
Though the advent of modern technology has developed a computer to plate network system used to expose and develop lithography plates. In this model, I will describe the immediate pass plate making method used in lithography. So which one is the pass plate making method?
Okay, so we are just coming to talk about the how to the plate that we spoke about. That is the the material that we used for the zinc and whatever. We want to see how best we'll use it. We'll use it to develop it. All right, for lithographic. Don't forget that in lithographic printing we use plate. Don't forget we use plate.
Okay.
We use plate for that, and it's the plate that is transferred. The image is transferred onto a rubber. Okay. So it is the plate that gives ink to the rubber for the rubber to rather print it. The essence of the rubber one is that it gives it a very fine edge and definite, precise, print. So that is why we are using it. Okay. So the equipment and materials used are plate maker, foam, zinc, developer, and gum Arabic. All right. So let's expose the image. How do you expose the image? Let's go. How is that
exposing the image? Position and fix the station at the coated side of the plate at right reading.
Okay, so don't forget that the plate is coated. So you fix the image, all right, at the coated side of the plate. Which chemical do we use to coat the plate? Which chemical? Which chemical? Quickly. Which chemical? Photosensitizer.
Photoemulsion.
Yes. Yeah.
Okay. The second point: place the plate in the plate maker, into brackets, a light box equipment, and close it.
All right. So that is how the plate is developed. So someone asks, how is the plate developed? That is what we are doing. Okay. Now let's go.
Set the exposure time.
All right. Just like the way we did the photographic screen printing.
Yes.
All right. Let's go.
Switch on the light in the plate maker to expose the image onto the plate. Remove the plate after exposure and develop.
All right. So now developing. So we are finished with the plate now. We are finished with the plate. How do we develop and preserve the plate now? Let's go.
Mix the plate developer with clean water into a ratio of 1:3. Into bracket, 1 part of the developer to 3 parts of the water. Second point: put the plate on a flat surface and pour the mixed developer on the exposed side. Spread the developer. Someone raise his hand.
Yeah, you finish so that you will ask his question.
Spread the developer evenly on the plate in a circular motion with foamed pad, and leave it for some time to soften the unexposed part of the plate to bring out the latent image. Wipe off the developer from the surface with a squeegee or foam pad. Rinse the plate with water and mop traces of water. Preserve the plate. This is done by applying a coat of gum Arabic at the exposed side of the plate with a foam pad. Allow the plate to dry and fix on a press plate cylinder for printing.
All right. So once you have developed your plate, you have developed your plate, you wipe off the developer, all right, from the surface with the squeegee or foam pad, and rinse the plate with water and mop with traces of water. Okay. Then you preserve it. You preserve it by applying gum Arabic on it at the exposed sides of the plate, all right, with foam pad. Then you allow it to get dry and ready for it to be slotted into the printer. That is the cylinder where the press plate cylinder is. Yeah. So now, your question before we move on. Eben.
Thank you, sir. Please, I want to know, in the course of expo.
We can't hear you, Eben. We can't hear you. You started well, but
Using the image on the plate. You see a plate or It can be in the
yeah. So you realize that most of these setups, most of this, when you go to Accra Newtown, you realize that when there was Doomsaw, you know, they lamented a lot. When there was Doomsaw those days, you know, they seriously lamented it was spoiling their business. Yeah, I hope you get it. Yeah, it will get spoiled. Okay.
Okay.
So most of them are having spare generators, especially when you are developing it. You need to switch on your spare generator, so that don't give chance as you overbook what I say. So don't give chance. Don't give chance. Switch it on. Use it to develop your plate and whatever. You're good to go. All right.
Okay.
So principles of reproducing a full color image in offset. So the principles. So we this is about color separation. Isn't one of my guys over there love the term color separation so much, and that is it. So half-tone plates are reproduced one after the other upon drying. So that is color separation idea. All right. Yellow is printed first, while black is printed last. Did I say this in printing technology 1?
Yes.
Yeah, I said something closer to it.
Yeah, you said something like the bright colors.
You said light colors are painted first
before the deep ones appear.
Fantastic. You people are good. Fantastic. You see, once again, just to let you understand
we have
that
to get another one.
There's no way. Is that?
I thought we'll get another one.
Another one, Mark.
Another one. Oh, but what if I'm giving you 5 this time? What if I'm giving all of you 5? I'm giving all of you 5. Let's go. Yes. Yeah. And education is not to come and fail anybody. If someone tells you education is meant to fail anybody, it's not true. Education is to transform. So once there's transformation, education has taken place. Simplicity. All right. So
lovely.
That's very artistic.
So let's move on. Let's move on to the next one quickly, so that we end it quickly. So if you read about this, that is the idea that I spoke about. So there's no need for us to read that again. So we move to the press machine, the press itself, the machine itself. Now we have been able to prepare the plate. We have been able to develop the plate. We have been able to slot the plate into the press, into the machine. So let's look at the machine itself. The machine itself. Yeah, Mavis.
So sorry, please. I would like to know why do we apply the gum arabic after exposed to the exposed areas after we have developed the plate?
So the gum arabic is for preservation. It's also a binder.
Okay, thank you, sir.
All right. Okay. Now let's go to the printer. So offset lithography press machines. So we are looking at the printer itself. The machine itself. So over here we are going to look at the 2 basic types of offset lithography press machine and describe the characteristics and uses. All right. Though this topic is interesting and very complicated, we are getting an understanding, and we have to. It's very, very, very compacted. We are still not done. Since this, we are still not done with 1 unit. That tells how compacted the concept is. But hopefully, we'll do it. Now, let me explain it. The 2. First, simple. I want you to get the simple terminology over here. We have 2 types of offset lithographic press. In short, we have 2 types of printer, which is lithographic printer. Please take note of it. 2 types. We have sheet-fed offset press and web-fed offset press. Let me explain it simplicity so that you will not forget it ever on earth. It's a sheet-fed. There's no need for us to read. So you can even write it in examination. When you say sheet fed, it means that pieces of individual papers are packed and slotted into the printer. So for instance, you go and buy A4, you know, the A4 size, that is in rim. Is that also? It is in rim. So you put all together and feed the machine at once. And feed the machine. So that is the sheet fed. So we are feeding the machine with sheets of papers. That is the. So there's a machine that is fed with sheet of papers. So the sheet of paper is cut. It's cut according to certain sizes. So it can be A4, it can be A3, it can be A2, it can be A1. So that is it. Please, are you okay with that?
Yes.
Okay.
Sure. Yes, sir.
Then web fed. So the web fed, that one, the paper is not cut in pieces. The paper is like a roller. The paper is rolled. The paper is rolled. Is like wrapped around a particular. I don't know what. Just like toilet paper. Friend is saying toilet roll.
Yeah.
Toilet roll. So good. Is it David who printed the backdrop? Is it David or who? Who printed the backdrop? Or Edmond? Which one? Who printed the backdrop? Who printed it?
David.
Prince.
Okay, Prince. So you realize that when you were printing the backdrop, you realize that the plotter is not sheet fed. The plotter is what? Well fed, because the machine, the plotter, the printer has rolls of what? The material. Is that also?
Yes, sir.
Roll of the support. So it's just like how we peel or we take our tea roll off. So that one we slot it. It's a drum. It's like a drum that has a lot of paper folded on it, wrapped around it. So we fix it into the printer for printing to take place. So when you finish printing, you cut. When you finish printing, you cut. So the printing is done in something like in a continuous form. So you have to cut it. You have to cut it.
I want to ask. Is it this kind of sheet that they use in printing receipt for this e-switch and other stuff?
Exactly.
Okay.
So much. I've given you people 0.5, 0.5 for that. 0.5. You understand it when you are failing. You understand it when you are failing. All right. Okay, so that is all. So that's the two forms. Please, have I given you an idea of the two types of printers that we have?
Yes.
Yes, sir.
All right. So it is sheet fed and web fed. Okay. So last one before we close for the day. Last one for us to end it today. Since we are on track. It's not even 4 o'clock yet. So maybe by 3:30 we'll finish. That is good. So Session 6. Where am I? Okay, Session 6. So now that we know the types of printing, now that we know the types of printers, we know how to prepare our plate, right? We know how to develop our plate, right? We know the types of printers that we'll use. How many types of printers? How many types of printers that we use?
Two.
All right. One. Someone should explain to me one. Don't read it. Someone should explain to me one type, and another person should explain the other. Who is explaining the one type? One type of the printer.
Sir, please, I would like to explain the sheet fed.
Okay.
So for the sheet fed, pieces of papers are packed or slotted into the printer, just like they are cut in pieces, just like we have the A4, the A3, and
fantastic
the bulk of them are slotted in there.
It's okay. You have done it. That's fantastic. That's fantastic, Mavis. Okay. Another person, a gentleman, well fed.
Sir, the well fed.
Yeah.
For the well fed, sheets are made in a continuous row around a cylinder placed in a machine for printing.
Fantastic. Fantastic. You have done it. You have done it. That is fantastic. Good job. So now that we have done, we are done with the types of printer.
Can I add something to that?
Okay.
With the word fed, after printing, the images are cut from the
Okay, so the papers are cut. The papers are cut. Okay. All right. That's good. That's good. Good point. That's good point. Now we want to know the operation system. How does it operate now? We want to operate the machine now. How does it operate? That's what we want to look at. That's the final section for us to end the rigorous unit 1. Yeah, that's the last session for us to end the rigorous unit 1. So let's look at how to operate it. So imagine you are there and they ask you to operate. That is what you want to look at. So this one too, we promise that this section, last session, will be very interesting section. So someone is reading for me. We have ample time, so someone is reading for me. But the person should read it before 4 o'clock. Yeah. Because we are all tired. I'm also tired. Everybody is tired.
Yeah.
Okay, let's go. Who is reading? Oh, I should read. Should I read?
Yeah,
should I make it simple?
Sir, I'm reading. No.
Okay. All right. Okay. Someone is reading.
The operating system of offset lithographic press machines is based on the following sections or units. In feed section, printing section, delivery section.
So if you want to operate the press, if you want to operate the printer, lithographic printer, you need to know that the operation is done in 3 sections. So you feed, you print, you deliver. You feed, you print, you deliver. You feed, you print, you deliver. Great. Now let's look at how we feed the machine. How do you feed it?
The paper is delivered into the printing section from here. The section
okay, so how
contains
many? So how is the paper delivered? How is the paper delivered? If they say the paper is delivered into the printing section, which 2 forms is the paper delivered? Which 2 forms?
Either in sheet fed or web fed.
Thank you very much. Thank you very much. Sheet fed or web fed. Thank you so much. Thank you so much. Okay. So we are done with that one. Okay. We are done, right?
Okay. All right.
So printing section. Let's go.
This section could be single or multiple color units, and each printing unit contains 1 or more printing couples. A printing couple contains inking and damping systems, plate, blanket, and impression cylinders, and each printing couple can print 1 color of ink.
And I hope I've already shown you a video, a diagram video of how the printing is done.
Yes, sure.
Show you a diagram video of what printing is done. So we are done with that. Done with that. All right, then we come to delivery.
This is the last section of the press where the printed sheets leave the press. The section contains the following important devices.
All right, so that particular section, the delivery section, contains, some important, devices that we need to take note of. The first one is ink dryer. Let's go.
This dries the ink on the printed sheet when it leaves the printing unit.
All right. 2.
Sheeter. This is a sharp blade which cuts the moving web sheet to a required section.
All right. So we said that once you are using the rolled one, the web fed, we have to cut the paper. We have to cut the paper. We have to cut the sheet. So the sheeter will cut the sheet for you. All right, let's go.
Combine sheeter and folder. This
All right.
fold the web.
This fold.
Okay. This fold the web into final sections and trims the sheet to size where no cutting and folding are required. The delivery section contains only a rewinder, which winds the printed web into row for later processing.
All right. So this is where that's the combine. We combine the two. So that's where collation takes place. Collation takes place. It said the fold, the web into final sections and trim. All right. The excess, trim the excess to size. So where no cutting and folding are required, the delivery section, contains only rewinder. So where we don't need to trim it, then there's a rewinder, which winds the printed web into the row for later processing. Now, David, yeah. David.
There's Prince.
Is it that one? Yeah,
yes,
Prince, yes.
Okay, so it says that some of the large format printers have the sheeter.
Okay, yeah. It has the sheeter. It has the sheeter. So after printing, it moves along and cut it for you.
Okay, because the ones I've seen is the ones they use in printing the bills and then the receipts.
Yeah, that one too is having sheeter. Sure.
Okay.
That one too is having sheeter. Sure. All right. So ladies and gentlemen, operating the offset lithography press, as we said, we have already described all this, how this operation takes place. All right. So that is all about everything over here. So ladies and gentlemen, we are done with unit 1. Thank you so much.
Thank you to sir.
Sir, please, I have a question. I don't know whether you've addressed it already or not.
Yes, ask your question.
All right, so between two and 3, I was off because of network issue and all that, and I also wanted to know if you've addressed this already, or if not, then you address it as well. Why is it that we need to convert our designs from RGB colors to CMYK, especially when we want to print it in a large format?
This is a very, very sophisticated, very intricate, very deep question that is not meant for children to answer. Okay, all right, so let me answer it. Let me answer it. Okay, so the R, that's the
RGB, blue green, RGB.
Yes, the RGB. When we are designing on the screen use that. Okay, the screen use that. Now the printer is having several colors that if you finish designing, all right, because whatever appear on the screen, if care is not taken, if you don't convert it, the outcome in the printer will be different. So there's a need for you to convert whatever is on the screen that you are seeing into the requirement of the printer, which is the CMYK. You have to convert it before you can get the exact color that you have seen on the screen and that of the printout. Please, have I explained myself clearer and better?
Yes, sir.
Yeah, so that is it. Next time, don't go and ask this question to a novice who teaches this concept. They will not be able to answer.
Well, like mostly when I go to the press, that's what they ask me to do before they print my organization.
So that is it. So when you go to the press, they will ask you to convert it because the printer, as if you don't convert it, you see that blue will become blue black.
Okay.
Blue become, you will not get the exact color that you are seeing on the screen of your laptop. So if you want to see the exact color of your screen on the laptop, it needs to synchronize with the colors that the printer uses. Okay. So you need to convert it into the printer mode so that the printer will accept it. I hope you get the point now.
Yes, please. But does that mean that those that use the CorelDRAW, their images, which is the vector images, automatically at CMYK, right?
Exactly. Okay. No, you can even convert. Me sometimes I even still convert all. Whether I'm using CorelDRAW or Photoshop, I still convert all. That's it. All right. Yes, any other question, Frank?
Yes, sir. Sir, please, I want to know from the discussion, it means that if I need a full color work, I need 4 plates so that each plate will take one of the colors. Is that the case?
Let me stop the presentation, I think. Okay, all right. Let's go. Yes. So that is it. That's a case. Full color.
Okay.
So you have several plates for each color. Several plates for each color. 1 plate for each color. Sorry, 1 plate for each color. 1 plate for each color.
Okay. Okay.
Christian, yeah.
Okay, sir, thank you. Sir, what I want my colleagues to know is that when you are printing out a document, you should always make sure you convert the file to CMYK.
Yeah.
But when you are showing on screens, that is your phone, on televisions, and all those stuff, save it as RG.
All right, thank you. So
when you are printing it out, CMYK.
So social media, that is the social media ads, and then the rest will be in the RGB, and then
just like what we are seeing over here, even just like what we are seeing over here, the interface that we are even seeing over here. Okay,
sure.
All right. Okay.
Thank you, sir.
Edmond is playing Ludo. Edmond is playing Ludo out there. All right. Okay. All right. Yes. Any other?
Sir.
Where is my friend? Before Raphael will ask his question, where is my friend who want to establish printing press? Why is Mohammed still in?
Absent.
So when I say that is a result, it is as a result of truancy and this irregularity. It will tell me network. At least he should show himself a bit for at least one second for us to know that he was here. So today he should come on the platform and come and tell us whether the photocopier machine we should print our work solely on that one. No, you will get it very soon. Then we also answer him very well. And as someone sent GIF, the GIF falling from the what tape is it chair? That tells how humorous the whole question was. Okay, all right. So yeah, Raphael, your final question.
Okay, sir, thank you. So about the lithographic printing, the stone that was used, the stone method. I want to ask if is that the indigenous way of
that's
indigenous.
We have said it several times.
Then the stone, is it a special kind of stone or they can
so
get
limestone? Limestone.
Okay.
But you can't go and use igneous rock. Do you know how dangerous and hard igneous rock is? You can't use igneous rock. Okay. So it should be limestone. Any soft stone would do.
Okay. So the offset is now the contemporary lithography we are talking about.
Yeah. We said that, Raphael. Since you were dozing off. You went to eat. I believe.
Oh, no. I was here. I was trying to note some of the things when it skipped me when they were reading. That's what I was asking.
All right. Ladies and gentlemen, you have done good job. You have done great work. At least you have realized that though the printing technology 2 is more complicated, more advanced, more sophisticated for you to comprehend. I believe the comprehension level is good, and your participatory level fantastic. If I'm giving the marks, I'm the captain of the ship over here, so far as marks is given. All right. So you would be appreciated. I like it when students contribute effectively to the development of sections. It makes learning and teaching very interesting. Yeah, man. It makes it very, very, very interesting. So what is your observation, so that we draw closure to it? What is your observation in today's first present? We did it for the first 1, 2, and when we are about to end the lesson we drew closure. So what is your observation on the first lesson so far as printing technology 2 is concerned? What is your observation on printing technology 2? What is it? Tell me. Share your thoughts. Yeah, so far.
Yeah.
What is your observation?
It's Christian too.
Yeah, Christian. Yeah.
Yes, sir. I've observed so many, but the most important one is, since you said you are going to be awarding marks for those who will be reading, all the books they came alive. Everybody was alive. But it has really awakened all the spirit that we've not heard our message for. So I think this formula will work for next time. Thank you very much.
And I can also counter what he said. But one thing is, some of us couldn't relate to the 1 because we were not familiar with it. But when it comes to the 2, with the printing, inkjet, and then large format printing, we are okay with that. We've seen some before, you've operated some before, so we could relate to. That is
exactly
why,
that is it.
Yeah, that's it.
All right, that's good. Any other observation?
Yeah, I also observed that from printing technology 1, most of the printing is done with human effort. Most activities is done with human effort, but the technology 2 solely relies on mechanical and electronic devices.
Great. Any other observation so far as the lesson is concerned? Any other observation? Any other comment?
Sir, please, I also like the fact that you gave PRAL videos and other relevant materials for us to look at before the lesson started. So it gave us a fair knowledge about what we were going to do.
Exactly.
So I'm very much pleased with that.
Okay.
Thank you.
So explain to Mohammed that those videos were not meant for him to edit. It was meant for him to watch. All right. All right. Okay. Well, Mohammed is in trouble here. Mohammed is in trouble here.
It has made him more popular.
Mohammed
your lecture has been so lively. In fact, I enjoyed your lectures too much.
But my brother Mohammed, if you're around, please say a word so that you can.
I'm even shocked that.
He's shy.
Oh my God.
All right. So, yes, Richard. Yes, Richard.
So my observation today, I realized that the lesson was more engaging than the previous ones, because today's lesson in particular, we were engaged more in the activity, like the reading, explanation sessions and others. But the previous ones, so that the concepts were not relatable, even though you were putting items for it, materials for it, for us to understand. More of the concepts look abstract, but today's own, in fact, we enjoyed it.
All right. Okay. Thank you so much. Thank you so much. That's his observation, Richard. Thank you so much. Yes. Any other? Okay. So let's draw closure to today's lesson. Someone should draw closure to today's lesson. Someone would do that. The better the closure, the better we end it with some marks. If not, we still take it like that. So
okay, sir.
Yes, who is doing the closure?
Mohammed will do the closure.
Then
most
if
of the
Mohammed is doing
adjustment.
the closure for today, I believe the
Understand?
closure would rather deduct some 6 or 10 marks from your marks, because he will be telling us, to establish businesses with the staffs there. They will begin to ask me, so how do you want us to get money to buy it? And I'll tell them for us to get loan. All right.
Where's Mohammed?
Okay, so finally, draw closure and let's end it. Let's end it.
Okay, so I, President Pond, draw the closure of the today's class. Thank you.
Oh, that's that.
I second.
This is not a meeting. No. This is so drawing closure over here basically is about giving us a bit of summary of all that we've done to the end. Something briefly. It can be just one sentence or whatever, just to. It can just be just a statement, but the statement should. It can be a sentence, a statement. It can be a brief recap of what something just to end it. So that's how we draw closure to a lesson. So this one has been too fast, like a military way of doing things. We are civilians. Okay, so who is doing that for us? Silence means what? Consent. Okay. All right. Okay. So today's lesson, we started with printing technology 2 as the first lesson. Unit 1 has been fully addressed. We look at 6 sections, and all the sections were taught in a very interactive way, and learners comprehended the subject matter better as compared to, most of them said that as compared to the previous one, which was more antiquated, this one is very modern. So they are abreast with modernity than antiquated era. So it ended on a joyful note where learners also had opportunity to accumulate certain CA marks because they have been able to contribute to the lesson development. I wish all of us the best. Tomorrow we shall meet the same time, and we want you to read ahead unit 2, and we shall get there. I wish you all the best. Thank you.
Happy New Year.
Yeah,
Thank you, sir.
All right.
Thank you, sir.
All right. Okay.
A happy New Year should be 10 marks.
Where's Mohammed? You are looking for
Please
Mohammed. What is he?
No chaos, no chaos. I beg.
You don't want chaos, eh?
No.
No, we have to look for Mohammed. Charlie.
But which Mohammed is being referred to over here? Because I'm not.
That one we are looking for, so that you know which one. But we have only one Mohammed here, or
I'm not the one.
you are not the one. Yeah.
Hey, my brother today he didn't speak. Oh.
He didn't. I spoke. Because yes, you don't listen. I wanted to ask a question. When they asked me that was I the Mohammed who was the person?
Okay. So no, you don't want any trouble, eh? This one is so interesting. Who wrote a marks down? You should give it to us.
Ima. Course rep, Ima.
Yes, sir.
Yeah. How far with the marks?
In fact, if possible, you can be calling them for us to know our marks so far.
Yeah, I want to believe that for the marks, I'm sure, yeah, it's been a lecturer.
Yeah, thank you very much.
Yes, thank you too. Thank you.
The call is being recorded though, so if we're in there.
Hello, Zema.
Yeah, yes, sir.
The document, can you get it for us, or it's already posted?
You mean
The
what
technology
is
too.
this? Oh yes, it's
Okay.
already.
Yes, I've gotten it. Thank you.
Yeah, you're welcome.
Christian too. Hello, Christian.